All right, hey everyone, welcome to Bitcoin Plus Plus. This is our, I think, going to be a damn good conference, so I hear. Yeah, really excited. Thank you for making the trip out here. I know it's probably our most exotic location yet. This is also maybe our most exotic theme. So for those of you, how many of you, this is your first Bitcoin Plus Plus event? It's like a handful of people. Awesome, welcome. Very excited to have you here. Believe it or not, this is the 15th edition of Bitcoin Plus Plus, but our first ever Villains edition. We are at the Hoover Dam in Nevada, in case you did not notice. Yeah, we are excited to be powered by Nakamoto. Did not show up. Okay, cool. Thank you to our sponsors before I kick off. We have two headline sponsors who are sponsoring our entire year of events. That's NIDIG and the Human Rights Foundation. Sponsors are very important to our conferences. Without them, what we do is not possible. So a big thank you to everyone that sponsored this event, but also especially these guys. Great. Okay. Also Stack, our workshop sponsor, who's sponsoring our whole year of events as well. This is a small event. We only have talks, but for events where we have workshops, thank you, Stack Works. Great. Okay. So without further ado, I kind of want to talk a little bit about why villains. Who am I? I'm Nifty, also known as Nifty Nye. I've been working in software since 2012, and I started working in open source Bitcoin in 2018. I've been doing Bitcoin Plus Plus since 2022. And working in software stuff, to be like, okay, are there villains? Surely there's not villains in Bitcoin, right? I mean, we know about villains in there's villains in media. We know what they look like. Sometimes they might try and blow up national infrastructure. There are perhaps some people and villains in Bitcoin that come up with controversial ideas about what should happen or how they think Bitcoin should change, etc. But I think there's also, a lot of people that have contributed to Bitcoin or the cypherpunk space in general, who maybe's ideas are like a little bit outside of normal. They're attempting to accomplish things that, depending on who you talk to, may be more villainous than not. Bitcoin is really an open source project. That means anyone who shows up can contribute their ideas, their pull requests, their suggestions, their comments. Some of these might be more controversial than others. And what is controversial, what is villainous, I think is kind of difficult to ascertain necessarily. Well, that's not totally true. I think with Craig Wright, it's pretty obvious that that's not things that we want to happen in Bitcoin, for example. But Bitcoin is sort of a interesting project in general because we have this idea of consensus, which means that in order for the protocol to move forward, we need a certain number of undefined participants in the open source ecosystem to come together and agree on which direction the project is going to move. And sometimes we have disagreements. People decide to go a different direction. We get forks in the protocol. People show up with ideas which are maybe a little too far outside of what is consensus and get treated as someone who is like, maybe ideas are not welcome particularly. Working in Bitcoin is hard. There's a lot of things you have to understand about cryptography, about how open source works, about C++. There's a lot of requirements, I think, in order to participate in Bitcoin at the technical level. And so I think, kind of where we start going with this consensus and everyone contributing is that we also, at some level, start requiring yet another skill on people that are operating in Bitcoin publicly at the open source level. And I think that's something called leadership, right? How do you get a lot of people to move together in the same direction when you don't have money to give them? Bitcoin's open source. Maybe you are all coming from different places, different cultures. Maybe you have slightly different values. I think what you end up seeing is that the way that the protocol moves forward is through techniques that you might in other places call leadership. What does that look like in open source? I think we're still kind of, and in Bitcoin in general, I think we're still figuring that out. Maybe it's not the person who's necessarily roaring the loudest about what they think is the right movement or direction, but the people who are showing up, doing the work consistently, putting out good ideas, and actually getting their hands dirty and contributing to where the protocol should move forward, that starts to look like how we move forward as an ecosystem. Cool. Because you know what's fun? Coming up with new ideas, creating things, shipping them, building them, getting other people excited about what we're making. Sometimes new ideas are controversial because they're new and they're different. And I think that as an ecosystem, we'll be able to move forward only if people have new ideas and are contributing new things that they're making in a way that enriches the entire ecosystem. So I'm very excited to have you all here at the frontier of Bitcoin. Also maybe at the frontier of engineering in America here at the Hoover Dam. I can't wait to see what you all have to contribute to the conversation on where Bitcoin is currently, what kinds of controversial ideas we might be able to add, or what projects we've done that we're proud of and excited about. So without further ado, I will get into announcements. Oh no, I didn't update. Okay, hopefully these animations don't. Great. I did say that this was going to be an unconference. I might have, lying isn't exactly the right word, but I ended up finding a bunch of talks that were on the schedule. There is a little bit of time on the tomorrow that I've called the open mic time. It is the same time as the tour. So if you want to hang out and talk and have open discussions, please make sure you go on the tour today. I'll talk about the tour stuff. Speaking of tours, is that on here? And for organizing this, there's a Telegram chat that you can all join. I don't know how to turn this off. I'm really sorry. Right, so we have a Telegram that we can help organize who wants to talk tomorrow. There's about 45 minutes for time to grab the mic. You can get 5 minutes, 10 minutes. We can figure that out. The Telegram is here. Okay, this one's not going to disappear on you. So if you're not in the Telegram group yet, please join here. I can also put this up later, or if you can't find it, come find me and I can get you in. Oh no, wait, someone got their phone out. Anyone else? Okay, great. Telegram's a great place to chit-chat about stuff. We also put up announcements there about transportation, etc. Speaking of stuff, so the schedule for today, you can find it online at btcpp.dev/comp/Vegas. Oh my God. Agenda. Alex Lewin has also printed out a bunch of paper schedules that we'll have up and around, so you'll be able to see what's coming up, unlike my slides. Just a quick stuff. We'll have breakfast starts at 9:30, which I think most people found next door, along with coffee. We'll break for lunch around 11:30 this morning, and then we'll have coffee break at 2:30, which will also be in the side room. Lunch break at 11:30 to 1. Just as okay, so we're also going to be going on tours. We're also going to be, I don't know if there's a way to stop it. No, that doesn't work. We're also going on tours today. So it is about an hour-long tour. They're going to start at 11:30 break. When you signed in, everyone got a badge. Your badge has on one side of it either an A or a B. The intention is that if you have an A badge, you will be going on the tour today. If you have a B badge, you can go tomorrow. If you decide that you want to go on a tour date different than the one on your badge, that's totally fine. You can change it up, but this is more of a suggestion. In order to go on the tour, you must be wearing closed-toed shoes. So these do not work. I have to go tomorrow. So I am going on the tomorrow tour, and I will be wearing the correct shoes. Cool. Any questions about tour stuff? Great. It's going to be a hard hat powered plant tour. You'll be getting a hard hat issued. I've been notified that it might be a little bit noisy on the tour today because they're doing a little bit of work refilling one of the reservoirs or something. I don't know. It sounded interesting. Cool. Okay. No questions about tours or schedule there. We're at the main stage. This is the only stage at this event. Next door is the catering and convos, and we'll open up the room for lunch so it's a little easier to move between them. Just in general, no photos at events. Of course, you're welcome to take my photo at this particular one, but I think we have one speaker tomorrow afternoon who also won't be recorded. So just in general, if you're going to take someone's picture, please ask before doing so. Of course, if you get someone's permission, that's totally fine, but please make sure you get that before taking pictures. Parking is free if you tell them you were the conference, just FYI. There is a parking garage up here. We're also running shuttles, which I believe a handful of you managed to take this morning, so congratulations. Okay, yeah. Great. Okay, what else have we got? I've got a merch store here. We've got some new hats. Very excited to have them. They're at check-in. You'll be able to get a hat with Bitcoin for $30. And without further ado, I think that is everything that I've got. I don't know where the time is, but up next, I think, is Jeremy Rubin from CHAR. We're going to get him up here to give a presentation. Maybe we'll take a 2-minute break. If you haven't gotten coffee or something yet, this would be a great time to do it. And then we'll be set up for Jeremy here in a second. So thank you, everyone, for coming out for Bitcoin plus Hoover Dam. Can't wait for the most villainous Bitcoin discussions yet. So thank you.
All right, bad tidings, my fellow evildoers. So for this talk, this is going to be CHAR if we were villain maxing, what we're not doing. But first, what is CHAR? What are we doing? Maybe let's clear the air on that first. In case anybody wants to say that we're actually doing good, this is what it would be. So CHAR is a sequence decision engine. We're producing a verifiable log of events that serve as pre-commits. The context of a pre-commit is something called a validium. This is a type of rollup, and these rollups work by posting onto the Bitcoin main chain a state diff, which is some kind of list of transactions and a proof of that, which can then be compressed somehow, maybe using zero-knowledge stuff. These validiums, you scan chain for these posted commitment bundles, and then a bridge can optimistically process withdrawals to users based on what actually gets posted to Bitcoin. And later, some withdrawal provider can refund themselves. That's kind of like the BitVM architecture. With pre-commits, these bundles of TXs can be committed by some party ahead of time so that you can have lower latency than every block. And also, some other benefits of just latency is also increased reorg tolerance. And you can decrease the frequency of your on-chain commitments. So if your pre-commitments are valid, let's say for a week, maybe your rollup only needs to post back once a week and you can take advantage of more cut-through. The biggest con of these pre-commits is that somebody has to make them. The simplest version of that is just some random guy. So for example, Bob here. And then you could unilaterally trust Bob up until the time that the pre-commit gets recorded into the chain. But Bob can maybe do some bad things like censoring or inserting transactions that benefit Bob. Censoring can also benefit Bob if you're using a more functionality chain with like a Uniswap or something. You could hold somebody into a trade that they don't want to be in. Bob can't really forge transactions though. So if you didn't make a transaction, Bob can't fake one. It's still cryptographically bound in that way. We don't really like Bob. That's why we're working on CHAR. Because we don't want to have a centralized coordinator party for all of our rollups. We want to be able to have a fully decentralized system. And so that's what we're building. And the main way that it works is Bitcoin is deposited in time-locked outputs. And we have some sort of epochs, periods of time, where we tally up the stake that is sufficiently locked. We collect signatures from that group of parties. They use something called a deterministic nonce using the Purify algorithm, which essentially lets us punish parties that double sign, that try and cheat in a Byzantine way. Applications can build pre-commits out of majority 2/3 sign decisions. Can you see the code? Not yet. Soon. Hopefully, we're trying to get an open source launch out this week. So fingers crossed that we'll make it. Purify is based on Musig DN, but it's publicly available here on GitHub, so you can see that now. Cool. Oh no, the top secret evil plan slide. Let's see. Okay, so what are we doing? We're going to try and take over the world. What we're going to do is we're going to get rid of proof of work on Bitcoin, and we are going to replace it with our proof of stake. So this is our hypothetical. What we would do if we were evil, we would be going for this plan. So first, here's how I would do it. Is I would start by making a sea lion post to the mailing list. And I'd say that we're gonna propose, just for good faith conversation, that we should switch to this new consensus algorithm, just to revisit the assumptions of if proof of work is the only answer. We would get roasted next. And so that once we receive the roasting, that's actually a necessary ingredient and component in our evil plan. It's sort of like an endorsement of the bad kind. You get the endorsement from the person, and it promotes your concept into relevancy, because now everyone's talking about what somebody else said about what you said, which is really good. Everyone in the bit devs, everybody knows that we're doing this. So it's really important that we get roasted. Then we rage quit. And this is actually part of the plan. We don't have to do much original thinking. We can learn from the master himself, Mike Hearn. And our goal would be to be in the New York Times as well. Okay, so the next step is that we're going to start a global energy crisis. And we have a couple different strategies for doing this. So strategy one is that we're going to cause a little bit of global warming. We're going to evaporate the water out of the dam, which is then going to increase the price of electricity, and we're going to cause a major problem for these proof of work driven things. So we're going to have that angle, but we believe in redundancy. So we're also going to, using our influence, we're going to escalate in the Strait of Hormuz, which is causing a liquid natural gas, crisis, which a lot of the miners are also, using whatever these, stranded energy assets, whatever. So we're gonna go for that angle. And then this is all putting things in the direction of like proof of work is really not looking so good with this energy becoming so scarce. And so that's really going to drive, proof of stake as an alternative into the common discourse. And we're going to start going with a very slow approach. We're going to start sequencing Bitcoin running with a 6-block lag. So this is going to be very popular with businesses, because there are all sorts of companies that try to run on Bitcoin, and they say, oh, what happens when there's a 6-block reorg and you've honored deposits? They really don't have very good contingencies. What they do is actually this traditional strategy of thoughts and prayers. So what we're going to target them with is saying, hey, look, if you can adopt this as your secret contingency plan, if there's ever a reorg, you have this other strategy for the consensus in Bitcoin that you can fall back on with a 6-block window. And in the event that Bitcoin does have a major reorg, they can say, oh, well, proof of work has clearly failed, and we're going to fall back to this other network, which has not reorged. So we'll get those relationships secured. And then we're going to add modes to our Core 32 client, which is going to expose only the char confirmed blocks, so you can run in full sync just with char. Next, what we'll do is we'll start decreasing that window. We'll start with, let's say, even 30 blocks, go to 6, to 3, and then to 1. But that's not all. So we're then going to add a mode for miners to use inside of block char precommits. So rather than having blocks still be selected by the miners, then it will be only pre-committed segments. And that will feed from the mempool, so you'll have segments that are basically committed by char faster than blocks happening. But we're not going to enforce that. We're just going to add a mode, but we're going to incentivize it. People are going to enact our plan on our behalf, because they'll be incentivized to exclusively use these pre-committed segments. Only at that point where everyone is doing this out of the goodness of their own heart and not their pocket, then we'll require that these exclusively pre-committed segments are used. Lastly, we will then force difficulty over every difficulty adjustment period to decrease. And eventually, we'll hit 0 difficulty, and we will have fully replaced proof of work with proof of stake. So this is not where we stop our plan. Now, with full control of the network, we upgrade Bitcoin. So pre-commits work best when you can do cut-through. Bitcoin transactions don't lend themselves naturally to cut-through. So we're going to restructure the transactions so we get some of these nice cut-through properties. We'll add post-quantum signatures. That will also, in our roadmap, engage another whole base of people who are very mad about what's happening in Bitcoin. We will also do, for the scalability issues with the post-quantum signatures, we'll do post-quantum ZK Stark compression over the witness data, which obviates, the concern of, these signatures are going to be big. They'll all get ZK compressed. We'll also add covenants and privacy features, trying to engage all possible bases of support to enact our evil plan. And then Bitcoin on the base chain, as a last note here, becomes all chains of op-truths to op-truths, which means that we'll keep 64-byte transactions enabled so that we can have these on-chain traces for legacy compatibility. By the way, this decreased transaction latency plus cut-through means that we can probably kill Lightning Network. And our evil agenda overall is that people can actually use Bitcoin. Now, that wraps up the thought experiment, but now we can talk about the thought experiment itself. Why isn't Bitcoin doing this? Well, there's a belief in proof of work and also in not wanting protocol changes. Why aren't we doing this as chars? Like, we're busy enough trying to make rollups work, and we're not evil, so we're not actually trying to do this kind of thing. But the real moral of the story is that we should probably think a little bit harder about what Bitcoin could be in 30 years and what we're doing today to get there, because, well, the way that I've discussed this topic is a little bit far-fetched today. It really is something that you can think about, is like, if Bitcoin worked exactly as it worked today in 30 years, that would be great. But if it was used by as many people today in 30 years, we might call it a failure because it hasn't really spread its sphere of influence and hasn't become a real globally useful currency asset. And so I think when you think about things like latency, or you think about how transactions are settled, what types of programmatic structures people can put their funds into, especially in terms of wills and estates, Bitcoin is pretty insufficient, and so we will at some point have to get there. So it's worth us envisioning, in the future, what we'll do to transition to these other things that are not somebody in a hat and glasses, trying to make an evil plan to take it over. And lastly, I'll say I'm not evil, but there probably are evil people out there who do have these plans for how they're going to take over Bitcoin and charge people, money for it, and own the protocol. And it's our job to not just resist them, but to provide a better alternative than what they're proposing. So thank you very much, everyone. I'll be right behind you. So whenever you go, buddy.
Are the 64-byte transactions to make sure we don't need to worry about bit 54 too?
Exactly, yeah. Any other questions?
In Ethereum, they needed the difficulty bomb to incentivize people to go out and proof of work. There wasn't much about incentivizing other than, I guess, just paying them directly. So it would have to be high amounts, right? Because they're giving up future potential profits, basically, right?
Yeah, so I didn't come up with an exact mechanism for that. You can probably set things up such that you can pay fees that are only if the bundle gets emitted. That would require some specific transaction structures to do that without other changes. Could also be some other thing for an evil plan to incentivize it.
But it's just monetary, because in Ethereum, monetary wasn't really enough. They just had to.
Well, so for Ethereum, the difficulty bomb wasn't a real thing. In a sense, because it was put off many times. So it's more akin to the knots software disables itself at a certain point. I think that they just thought it was cute to make it the software doesn't technically turn off, it just gets really slow. So I kind of think that the difficulty bomb wasn't a real thing given how many times it was deferred, if that makes sense. Yep.
Have you considered part of this evil plan that it might be better to, rather than switching entirely off proof of work to proof of stake, to transitioning into a hybrid system that is 50% proof of work, 50% proof of stake?
Well, yeah. So that was kind of in the concept of you could let the proof of work component drop down. I think the part of the dynamic that would emerge is that there'd be a natural fall off because proof of work is only really worth paying for to the extent that it is, especially in the future, causing fee revenue. And if people are preferring to pay to the sequencer side, then there's less fee revenue that would be going to the miners, and there'd be natural market process that would decrease the proof of work component. The main area, by the way, where this type of proposal is weak is that you have these sort of subjectivity issues where if you don't have proof of work, then your changeover of the staking committees is not really strong. So you can kind of re-simulate history without proof of work.
Right. What I was thinking of is
kind of like a multi-algo. You know how like there are chains that have like multi-algos where they have this automatically rebalancing between the two, like doing something like that and just persisting that over time. It certainly
Yeah.
it seems to be
I
easier.
I think if I were going down the route of really wanting to make a true hybrid from scratch, it would be more like and I know it's a little bit panned right now in Ethereum, but more the VDF direction, because you're really just looking for impossibility to simulate. You're not necessarily looking for proof of work, if that makes sense.
Okay.
Yeah, I mean, again, this isn't a real proposal, so this is just like a joke. All right. Well, thank you, everyone.
All right. Thank you.
Okay, so I have this project called OperaTurnBot, and basically the idea is to spam the network and kill Bitcoin. But who here has used it? I'm curious. All right, well, thank you for paying for my lunch. Okay, so who am I? I'm Ben Carmen, Bitcoin and Lightning dev. I live in Austin. I make things that the mempool filter crowd hates, but I also work on things that get killed by full mempools. So it's a tough life, but we get by. Yeah, I made this service called OperaTurnBot. If you know what it is, you pay a Lightning invoice and you get to write a message onto the Bitcoin blockchain. It's really simple to use. It's text box and QR code. But it's cool. People announce like childbirths. I saw someone today like celebrated their nephew's birthday. People do weddings, memorials, and then people put memes on there. They'll protest filters. It's it's the world's soapbox, but it's fun. So I started this in 2020, right around the halving. I wanted to like turn a message into the halving block, and so I made like a stupid CLI tool in Bitcoin S, which is like a Scala implementation of Bitcoin. And I like tweeted out like, oh look, I OperaTurn this, and people were like, oh that's cool. And then since people saw that, I became like the OperaTurn guy, and people would DM me like, hey, my child's being born tomorrow, can you OperaTurn this for me? And like, I had to do like 50 of these. Like they'd happen like all the time where people would be like, yeah, you were the first person to know my child was born because I needed to get that OperaTurn in immediately. And I was like, there's a lot of responsibility here. Like you should tell your mom, bro. But it was fun, but it ended up getting like a lot. Or like people would be like, I live in Australia, but I need you to DM or do it at this time. I'm like, dude, I'm not waking up at 4 a.m. for your OperaTurn. So, I built a service. So that was like my first like real project that wasn't like employed by. It was like an actual side project, but it was fun. I learned a shit ton from it. I like host it on a server or on a laptop in my closet, and it's always been there. And I just like proxy it through. I used to proxy through Tor, so it's very slow, but now it proxies through like a proper server and everything. And it's taught me a ton about infra and actually building live service apps. And for this whole time it was like this very simple thing, maybe like maybe $5 a week, but it's mostly a learning thing. But it also when I launched it, I burned 1 million sats. That was a great time. So if you don't know, in Bitcoin we have multiple versions, or multiple ways to say fee rates, and I was converting sats per kiloweight to sats per vbyte, and I did it wrong and 16x overpaid. So and then on launch day you get like 50 users, so they all overpaid by 16x, and just all my money was gone. And at first I was like, oh man, this will never pay back. I just burned my money for nothing, but you'll see otherwise. But yeah, I eventually made it back, and it was going well. And then, but it was like, maybe a couple a week, maybe made like $100 in total, but it was fun. And then Peter Todd, I think he's here, maybe not, but he released Libra Relay, and I was like, oh, unlimited size OperaTurns, I could make way more money, I could do so much more stuff. So I switched my node over and tested it out, and it worked. But my initial issue was like, okay, now if I do these large OperaTurns, they can only be mined by MAR or F2 pool. They're the only ones that are actually mining these. And I would get this issue where if someone publishes an OperaTurn they want to do, the fee might be like 5 sats per vbyte now, but MAR and or F2 pool might not mine a block for a few hours, and fees might go up. And if I miss that one, then it's like, okay, now I got to wait another 2 hours and stuff like that. So I'd like drastically increase fees. This is like the code change where I just basically double the fee if you're over the 80 byte limit, and that mostly solved the issue. It made me more money as well, so that was nice, but it was fun. So yeah, this is what's it called? Pre-large op returns. I did about 1,600, so like a quarter of a block, and 5 million in sats and fees to the miners. So like decent amount, but nothing like crazy. And we had some fun stuff. So if you guys know Sahil, I op returned this picture of him into the blockchain. I think this one here is Peter Todd op returning different knots people's messages into the blockchain. I think Shinobi op returned an entire Bitcoin Magazine article into the blockchain. That actually so I have a Telegram bot that messages me someone just op returned and gives me the message and a bunch of stats. And Shinobi's article broke my Telegram bot because the message was too long and it exceeded the Telegram limit, which I thought was funny. It was Telegram broke, but Bitcoin still worked. So it's a little slightly beautiful, slightly Dude, I can't let you out stuff. But so yeah, life was still after the initial boom of the big op returns, it was whatever. We had 3 to 5 transactions a week. I'll get a ping when it happens, but the project was still very hacky. There's no queuing system, no error handling. It just mostly worked. There's never really any edge cases besides fees weren't high enough, and that's easy to solve. But then one day I wake up and someone has op returned a pump.fun coin. And then they're also op returning through my thing. We're doing giveaways, blah blah blah, and I'm getting the coin goes up to $185,000 all-time high. All this shit, I have no idea what's going on. I get these DMs bro, go push your coin, blah blah blah, and I tweet out I have no idea what this is. Stop asking me. This is a scam. I get this guy with this very heartfelt message being this is so. I think he thought I bridged Solana and Bitcoin through op returns. He's this is so cool. You've done this incredible feat and all this stuff, and I can't wait to see what more you build. Blah blah blah. I'm just it was a very nice message, but I just sent my tweet. I'm dude, this is a scam, bro. Don't think. And then so this got it all on the shitcoiners radar, and then a couple days later I wake up and I have 500 orders when I wake up, and I'm what the hell happened? At first I thought someone exploited my bot and they're just burning my money. What is happening? But I go and check in, log in my server in my underwear, and look, all the money's there. I'm wait, what? Is this all profit? So then, this is my dashboard. It's just straight up. I'm this, this isn't mail-in ballots. This is, this is op returns, and so that was crazy. So what happened was, if you guys know what BRC20 is, it's the ordinal's way to do tokens. During all the op return drama, people made op20 in this apparently in the Chinese WeChat group, and basically all of them were racing to mint their tokens, and my bot was the easiest way to do it. So here I am, and so this is the initial one where they created the token. I found this morning. I was I should actually go find it, and so someone created it, and then there's basically just thousands of these where they're doing the op20 and they're minting their things to their address. Funny enough, a lot of most people got it right, but there are some of them where they would drop a curly brace or a colon or something and have invalid JSON. So it's Jesus Christ, are you manually typing in JSON into this thing? But they're serious about the project. But so that was interesting. And but the main issue I was having is I need Mara and F2 pool to mine my transactions. But I woke up with 500 orders and only 90 transactions have been broadcast. So I'm well, that's not good. My project has no server, no error handling. So they just see pay invoice, and then the way it worked before is it would wait for the transaction to be broadcast and then give you the success screen. But they're not seeing any success screen, not even an error screen. They're just what the hell happened? Because basically what happened is I use L&D's wallet for creating the transactions, and it uses a random UTXO selection, but it does not take into account ancestor limits. So it would just randomly pick a UTXO and then create the transaction. But eventually it would either exhaust the ancestor limit, or sometimes it would just pick one that's exhausted and have one that wasn't, and it would just be not satisfying anyone's order. And but I still took their money. So my DMs are filled with like, yo, I just paid this bot, and it's like he thought the invoice he paid to deposit was his address, like it would be in like Solana or something. I'm like, dude, that's Blink's node. That's not my invoice. But and then I get ones like this is a Chinese guy. He's like long time, but it's not work. Like so, having all these issues like, what the hell's happening? And I'm like, it'll process it, I promise. But I'm getting like tons of these, so I'm like, okay, I gotta fix it. So like in my underwear, like I gotta rewrite this entire project basically. And this is like Claude and ChatGPT were not good enough for coding yet, so this is like all by hand. But eventually, like the project's like a lot better. Now I have like proper error handling now. We have like warnings for all these ancestor element stuff. I manually do UTXO selection now instead of like relying on LND. And because of that, now I have to do my own concurrency stuff instead of like letting LND handle that. And then I had to like go into my cold storage and like add a ton more UTXOs to the wallet so I can actually like go through these. And that like was initially like, okay, it'll solve, right? And not really, because I'm still waiting like every few hours for a single block. And fees are going crazy because like apparently lots of different people are doing this, and not just through my bot. They're like either manually broadcasting it themselves or doing stuff. So like fees are like spiking, and my transactions aren't really getting through. And these are all non-standard. So yeah, I'm just hoping F2Pool and Mara will find blocks, and hoping that my transactions will have to actually be in them. But eventually I got them cleared in all one block, because what I did was just hike up my ancestor limit to 250, and that let my mempool fill up with everything. And I got a direct connection with Mara, who also had an ancestor limit of 250. And my entire backlog was cleared in a single block, so that was pretty exciting. So you can see on mempool space, this was basically my entire mempool got into a single block. And so all the blue ones here on the right were blocks that were not seen in the mempool. So you could see, filters are really working here. So yeah, I was only breaking two rules: was the opportune limit and the ancestor chain limit. And these are both just config options in core. I just changed them and got a direct connection, and everything worked. But we'll see. But yeah, so like I said, these are just settings, and you just direct connect, and it's pretty easy to get around. So it kind of shows like all these filter stuff is like kind of moot. Like a lot of the arguments people would say was like, oh, you're paying double fees for the extra over 80 bytes. That's like an extra cost. It's like, well, I'm only doing that not because of the filters, but because of the miners aren't mining them. So like I said, these direct connections kind of solve everything. And Libra Relay does like the preferential peering, so that solved it as well. Like I really wasn't being affected by filters at all. It was more like the actual miners. So yeah, the day of the stats, we did 3,000 op returns, 3,075. About 0.8 virtual megabytes, like almost 80% of a block, and 7 million in fees in a single day. So it like dwarfed the entire project from beforehand. So yeah, filters don't work. Definitely don't need like one dev or a server to get around any of it. No, don't just like DM someone and get it over with. But yeah, so these policies were great, and that was pretty fun. So yeah, but it taught me a lot. The project's been rewritten. Now it doesn't use LND's wallet. I moved to Bitcoin Core because it has better coin selection and everything. We handle all this ancestor stuff. And yeah, another issue was like, even if their transaction got broadcast and it was in the mempool, it was like they wouldn't see anything because mempool space doesn't show non-standard transactions. So I created benpool space that uses my node, so it sees all these stuff. So yeah, some fun stats is in its lifetime now it's done 5,000 op returns, 81% of which were non-standard, and we've done over a block now, still even in non-standard, and 15 million sats in fees to miners. So you're welcome, miners. And in the meantime too, I built this thing called mempool radar that lets you see everything that goes through my nodes, so you can get notified about like non-standard transactions. And these days it gets spammed by all these annex transactions because I don't know, some ordinals thing they put an annex in there to like go to a different miner. But it also like call out these 4 megas too, which is fun. So it's fun thing to follow. I found the someone did the quantum proof without softworks thing. I found it through there as well. So it's a fun follow. So yeah, these filters are theater, and OpReturnBot still works, and it's never been better. All right. Any questions?
So the ancestor limit was basically the wallet was like you would create a transaction. Is this on?
No.
Switch it on. Oh. Switch on. Hello. Sorry, 1 second. I can just speak loudly. I have one more button to press. Okay. 3, 2, 1, go.
There we go.
Hey. So the ancestor limit was basically you would broadcast a transaction, there would be change, and then the next one would pick the change, and then they would just chain. And because you had so many going at once, it hit the limit.
Yeah. Basically, it'd be like I think my wallet before only had like 3 TXOs, so like 75 orders would fill that
So
up
they just
immediately.
kept on chaining, right?
Yeah. So and then like because like LND wouldn't even like allow you to do the transaction then, so it's just like the whole thing order would fail. And yeah, I mean luckily my database I kept everything, so I wasn't able to I wasn't burning people's money, but we eventually got them all processed. Yeah.
How much money did you make?
I'll tell you afterwards.
But you got to be villain maxing, so you got
Well,
to put it out there.
Yeah, but like the government exists.
All right.
Literally, like right.
Yeah, we're at a government building.
Have you thought about doing an update to this too? Because I'm thinking about what you can do for op returns, multiple op returns in a transaction.
So yeah, when I first made it, I was like, oh, I can get around this 80 byte limit by having multiple op returns, but it turns out that was non-standard too. I mean, I thought about it, but it's like, what's really the point now? Because you have the 100 kilobytes. I mean, maybe. My most requested feature now is like having an option to like upload files and do that. But I'm just like, I'm scared about child porn, and I don't want to be like the guy that goes down for that. I was asking like some like ordinals people, like how do the ordinals people solve this? And apparently they just don't. So I was like, oh, maybe I could just allow it, but I have not braved that storm yet. Yeah. Yeah, there's like a database of them, but
I mean, this is Section 230, right? It's like,
Section
wow, I'm just the platform. I'm not the facility.
yeah, I don't wanna fight that.
I had another question. So, does OpReturnBot have an API, or is this all like manual entry in a website?
There is an API. I don't think anyone knows about it, but it does exist. But yeah, I think they're at 99% through the web.
Man, so like in all of those the shitcoins that people were broadcasting, it was all manual. I mean, that's why you had the JSON errors, right?
Yeah. I think they're all just like copy pasting JSON into there.
API would be great with like AI bots now too, right?
Yeah.
You should put up an MCP server.
There's like 5 or 6 different. OpReturnBot's like kind of like my hackerspace. So like you can like DM it on Nostr, and it'll give you a QR code to whatever you DM it to do that. You could send it like an onion message, and it'll handle that. At least it used to. I think there's an MCP server, and there might be. There's an MCP server, and there's an API all to do it. So there's like different ways to interact with it, but they're mostly just hackathon projects.
I have 2 questions. One, what inspired you to name your site benpool.space?
It was mempool, and I was like, what rhymes with mempool? Benpool. So.
Oh, I love it. And then do you have a sense of like who are these people using OpReturnBot? Do you have a sense of the demographics? This
Yeah,
guy?
Shinobi. Yeah, people who hate Bitcoin. I don't know. I mean, honestly, like probably like 80+%. Besides this day, like 80+% are probably just like either like wedding or like childbirth or like or like my grandpa died, like long may he live kind of thing. Like they're mostly like family tributes, stuff like that. Yeah, no, it's fun because I was just like sitting there and I get a Telegram notification and be like, my child was born. I was like, oh hell yeah, like more Bitcoiners in the world. So it's mostly heartwarming. And then sometimes you'll just get like I remember like someone like would do like Dieter Bob hates women or something. It's just like, you know, random stuff like that. So that's always fun too.
I wanted to go point out, I mean, I've used it multiple times, even though, of course, I have scripts that could just do it. Because it's the easiest way to have someone else's coins be the thing that puts it in.
Yeah, yeah.
And then Lightning gives you privacy.
No, yeah. So funny, like a long project ago, I made like Vortex to try to do coin joins in Lightning, and the main inspiration was like anyone can pay like $2 to do an op return and find one of my UTXOs. It's terrible privacy, so I have to be very careful with the nodes or the funds on there.
Can you check the bot now to see the most recent op return that was done?
I can just check on my phone. This Ben the Carman talk about op return at Bitcoin Plus Plus edition sucks. But with that, fuck you guys.
All right. Hello, everybody. I'm Ekrem, one of the co-creators of Citria, and so Citria. Oh. Okay. I'm gonna shit on BitVM3 and BinoHash. They're good, but they don't fundamentally improve the bridge security. But let's start with what are we trying to achieve? We're trying to have a plausible use case for large op returns to make spamming on Bitcoin easier. Just kidding. We're trying to achieve to build better bridges. We want to build the best possible bridge. Why? Because we want to have these applications that can use BTC in a programmable environment. For example, like Zcash style privacy apps, Bitcoin lending borrowings, and agentic payments, and this list goes on. So to have the best bridge, we need to have the most secure bridge. And the security comes down to two things, safety and liveness. So safety means bad things don't happen. Liveness means good things eventually happen. So in the context of bridges, safety is the bridge funds don't get stolen, and the liveness is whenever you do a withdrawal, you would be able to get your BTC back. So we have built this trust minimized bridge using BitVM2, and the security model is safety is 1 of n, where n is the number of signers, where they do this bunch of pre-signing during deposit time. And the liveness is 1 of m, which m is the number of operators, and at the worst case, they just pay the withdrawals to the users. So since we built this, there has been some breakthroughs, like BitVM3, BinoHash, pipes. And yeah, some people say it's like 10x improvements, it's like going to crush it. But it all comes down to these trust assumptions, and it doesn't fundamentally improve the trust assumptions. So I'm gonna talk about these. But let's start with what is BitVM briefly. It's a way to verify a ZK proof on Bitcoin. It consists of this assert and disprove transactions. This challenge transaction is optional. So you start a challenge by sending a challenge transaction, and then the operator responds with sending an assert transaction, which is basically operators signing the ZK proof. And then if the proof is invalid, anybody can send the disprove transaction. What is BitVM3? It's an efficient way of doing BitVM using garbled circuits. The initial efforts was doing garbled circuits using like YAO-style garbling, but later Liam found a great way of doing a Groth16 verifier that has only 25 megabytes of table size. But this table size doesn't do anything about the bridge security. It's just for the implementation, making the implementation easier. So now we have an easy implementation for the garbled circuit for the BitVM3. So let's talk about transaction sizes. And here you can see the BitVM2, the assert transaction was 1.3 megabytes, and then now it's on the order of kilobytes. Disprove transaction was like 4 megabytes, a whole block. Now it's like tiny, you cannot even see it here. So yeah, these are the sizes now. But what are these sizes even mean? Does this make my bridge safer? Let's say, does it make my bridge secure? And the answer is not directly. So these sizes affect the operator's initial collateral, where you can basically calculate the collateral required for a search transaction size plus the disproved transaction size multiplied by the maximum expected fee rate. This is because like when you have the bridge, you would want to be able to send this disproved transaction using operator's funds. Or you can say that, oh, some good people will send it, even though it costs like more than 1 BTC. And I don't think it's true. I think a secure bridge needs to well incentivize for sending these disprove and challenge transaction. And this is what operator's collateral is for. And if we have a smaller disprove transaction, operator's collateral can be effectively 0. So TLDR, BitVM3 makes collateral requirements lower. It makes being an operator easy. And then now the bridge can have more operators cheaply. Well, with BitVM2, there can be also more operators, but you need to pay more. So it just makes being an operator easy. There's also one more nuance, where with BitVM2, the disproved transaction was non-standard. But with BitVM3, now the disproved transaction is really small standard transaction, which makes it easier to send. Like in the case where you need to disprove with a non-standard transaction, you would need to agree with a miner. With a standard transaction, it's now both cheap and also you can just send it to the P2P layer. All right, so yeah, we are working towards upgrading our bridge to BitVM3 to cheaply scale the number of operators we have. But note that the safety is still one of n, which is harder to scale, because all these signers need to do this pre-signing. They need to be live at the time of deposit. OK, the next problem is how to prove something about Bitcoin. This is what we call a Bitcoin light client on Bitcoin problem. We solve this problem in our bridge using large op returns, where a challenge transaction signs a longest chain proof, and now the operator needs to respond with a proof that has a longer chain than the challenged proof. So this works. This also has one of n trust assumption. But Robin Linus came up with a new scheme that you can do transaction introspection. So yeah, BinoHash allows one to construct BitVM proofs about a transaction that spends a specific output. The way we do introspection is using longest chain proofs, so we can read all of the transactions on the latest finalized block hash with one of n trust assumption, and also assuming that the adversary doesn't control more than 45% of Bitcoin's hash rate. But this initially looks like much better scheme. But what are the trade-offs? So let me explain the BinoHash as a black box. The operator creates a BinoHash output. This is non-standard, but I don't want to get into implementation details. So you create a BinoHash output. Later, during your withdrawal, you can spend your BinoHash output along with a read output, where this read output gets into the TX ID of the spending transaction of this BinoHash output, and you can prove things about it in a different transaction, in a garbled circuit, in a BitVM. So in a graph, on the left side, you can see the operator's garbled circuit TX, which creates two outputs. One is the garbled circuit output, the other one is BinoHash output. So the read transaction below is that's the BinoHash transaction, basically. It spends the BinoHash output, but to be able to spend it, you need to do all this grinding, find and delete bug, all these non-standard quirks to be able to have that read transactions TX ID inside the ZK proof here. And then you also need to have these like disprove transaction where if the operator provides a proof but doesn't provide a read transaction, then you would be able to disprove. Or if the operator put an incorrect proof, you would be able to disprove. So yeah. But to have this read transaction to have a value, you need to feed it. You need to feed it with the rollups data. If you're building a rollup bridge using binohash. So now there's this problem where rollup datas, they use inscriptions. There's this commit, reveal, and you would want to combine all these into a single UTXO and then feed it into the read transaction. But the actors publishing these rollup transactions are different than the bridge actors, which are operators who are using this binohash. So if sequencer doesn't spend its output to be able to spend by operator, then the operator will fail to provide any proof about the rollup. So we've been researching on this, and the only solution we could came up with was to have this publish transaction where it enforces the sequencer to have an output per operator. So we did this all BitVM3 research to be able to scale the number of operators, but then with the binohash, if you want to scale, if you want to have 1,000 operators, then all of your publish transaction needs to have 1,000 outputs just to guarantee that the operator will be able to provide proofs about this state of the rollup. And yeah, one can say, oh, like let's publish this publish transaction rarely once in a day. But this transaction is what makes the rollup's finality. Like if it's once a day, then all of your transactions in between doesn't get finality. So TLDR, as of now, as far as I know, there's this trade-off of if you want to use binohash, then the published transactions get a lot larger and you cannot scale the number of operators. So, as I said, the main bottleneck is the N-of-N signing committee. With BitVM3, we can scale the number of operators. But the number of signers, they need to be online at the time of deposit, so it's limited. So which opcodes would improve the N-of-N signing committee requirement? So let's look at what this signing committee does. It's not doing anything complex. It's just doing bunch of pre-signing for the deposit, and all the arrows below is either signed by an operator or watchtower or user or challenger, anybody. So the only thing we need to do is to restrict this deposit to only be spent with this reimbursed connectors. And this is called input committing covenant. So there's also like two types of softworks that could improve BitVM-based bridges. One is getting rid of the signing committee, but still having operators that help with the liquidity. And the other type of softwork would be having recursive covenants plus a ZK verifier where you don't even need the operators to be providing liquidity. So for input committing covenants, optxhash, object contract verify, opcat, these all work. And with opctv, there's a hacky way of doing this where you can commit to sibling inputs because it commits to the script sig as well. But yeah, we would prefer doing this in a standard way, in a proper way. Okay, what's the other? Say it again? Yeah, opcat is also a hacky way, but not hacky as CTV is, I would say. So the other, the ideal bridge would be like having this rollup output where there's no like BitVM or bridge. It's just the single output, getting deposits in and then getting withdrawals out, and it just rolls over. This would be like, I don't want to say trustless, but this would be the trustless way of doing rollups on Bitcoin at the end of the day. And great script reservation, opcat, and maybe opcat plus txhash would be a cleaner way of doing this. Thank you for listening, and we are on mainnet, so if you have questions also, you can say.
I'll bring the mic to you just one second.
I'm stressed, what are you gonna ask?
That was great. My question is, the thing you described of the trustless roll-up would be just, money goes in, money goes out, and there's not this having to do the commitment and all that. Isn't that just drive chains?
So the difference is the Bitcoin script restricts this, and with the drive chains, there's no. You'd basically trusting miners, but this one you'd be trusting the full nodes as well. So yeah.
Cool.
Can you explain why, like, you had the list of where you needed like an output per operator? Like, why do you need that? Why can't you just like have like a taproot tree of all their keys instead or something?
Oh, so if the published transaction has one output where it all has like in a taproot tree operators keys, a malicious operator can just spend it, and then none of the operators will be able to prove anything about that published transaction. So you would need a different output.
Okay, that makes sense.
So it's my understanding, like with the original BitVM2 paper, that the signers deleted their keys. But in the current implementations, I think all the rollups, the signers keep the keys and have this like happy path withdrawal where it's N of N.
Mm-hmm.
If you switch to BitVM3 and were able to scale the operator set, would that change your opinion on deleting the signer keys or keeping them in place still?
No, my opinion is deleting the keys doesn't help, because at the end of the day, you would need another key which authorizes the new keys. So for every deposit, what would happen is like they would say, oh, this is my new key's public key. I'm going to sign this current deposit with this, and then I'm going to delete it. But if you also have a like root key, then you won't want to delete the root key, because that's what authorizing the ephemeral keys. And if you also have that, there's no meaning. It's still the same trust assumption. If they all get compromised, they can just do a bunch of fake deposits and then withdraw all the money in the bridge. So the risks are similar, even though they delete the keys. Thank you. All right.
Thank you.
Thank you.
So I'm here to talk about breaking ossification, and I think in some ways this is a direct follow-on to Buck's talk earlier about how governance had moved to the mempool. He was talking about how we haven't had a consensus change in 5 years, and we haven't had one that wasn't coded by Peter Wulla in a decade. So I do think it's important that we break ossification, and I don't know that I know exactly how to do it or anything, but I have some thoughts about where we are and where we might be going on that. So background, and this kind of again tails off of where Buck was coming from, but in Bitcoin, since some of the OGs in Bitcoin kind of stepped back from active consensus development, there's not really cultural leadership of Bitcoin. There's no one that people trust to shepherd the protocol forward. We have Bitcoin core developers, they're really janitors. They keep the system running, they keep the releases coming, they improve things, especially in the mempool. But there's no one where if we were to ask, hey, what should we do next with Bitcoin, the protocol at the consensus layer? I don't think anyone in Bitcoin really knows who to ask right now. So there's no leadership really. There's no obvious next steps. With SegWit, it was kind of there's almost obviously two ways to go there. We either go segregated witness, where we solve malleability that way, or we go a series of changes. I think Peter Wulla wrote them all down. We have to make to get to fix transaction malleability without segregated witness. We had to do that because many things that involve pre-signed transactions don't work without some kind of malleability fix or workaround for malleability. We could have also done something like CTV or Ccash no input at the time. So we had like 3 choices, and we did one of them. Great, so that was done. And then Taproot, I don't know if it was an obvious next step, but we had cultural leaderships we got there. Yeah, but then there's nothing now. What do we do next? No one really knows. Also, we have the problem. The previous talk was about threats to Bitcoin, but I don't see what he was saying as a threat. And I guess my point here is just that there aren't threats to Bitcoin right now. Without active threats to things that could make Bitcoin work less well, or where we could, lose the footing we have, it's harder to know what changes to make to Bitcoin in the absence of major threats. I think this is part of why we see some of the chatter we see where minor things that don't matter, like the full RBF change or the op return change, they make all this noise. They're perceived as threats, not because they're actual threats, but because there are no real threats out there right now. And I think this is a real problem that is making it hard for Bitcoin to improve. Similarly, it's been years now since the last major exchange hack. And it used to be that exchange hacks pushed people into self-custody, and that push to self-custody drove up on-chain fees. And the high on-chain fees, would drive consensus changes, right? Even to some degree, Taproot could be looked at as a result of trying to be able to do more on-chain. Taproot transactions have that key spend, low-cost option available to them that lets even complex contracts resolve cooperatively very inexpensively. And so we used to respond to, oh, there's exchange hacks, everyone wants to go on-chain, now there's high fees, now we need a consensus change. That hasn't happened in years. And then, in addition to the lack of threats and the lack of exchange hacks, we have trauma. We have institutional trauma from past events, whether it be the block size wars. If some people have trauma from that, I got yelled at on the mailing list for sounding like someone who had been involved in the block size wars. And there really is. There's trauma out there from these events where there was a real threat of businesses trying to take over Bitcoin, and people think that things look kind of like that, and now there's a trauma response to things that look anything like those old threats. And then some people have similar opinions about Taproot. I don't think they're that important, but they do. But now, in the year 2026, we have emerging threats. Is quantum a threat that could break Bitcoin? Many know my opinion on that, but at least it's something that people are talking about as a real threat. And I think it's important, and it's good. And I keep saying this when I talk about quantum. I don't think necessarily that quantum's a real threat, but I'm glad we're talking about the fact that we should be changing Bitcoin. There's going to be, with almost 100% certainty, a break of Bitcoin's cryptography at some point. Crypto systems just don't last forever. That's not the nature of the beast. They're a technique for securing data that is right now effective, and you should always expect them to break, whether it's the Enigma machine or MD5 or SHA-1 or RSA 1024-bit keys, whatever the thing is, or kind of the old mode of AES, right? We've gone through many crypto systems, they get broken. We should expect that, and I'm glad that quantum is kind of pushing us to have that conversation. We also have the threat of suits. We joked a lot for a while about the other Bitcoin conference that'll be happening, the sideshow that'll be happening next week as the Suitcoin conference. And I think that's really true. It's a Suitcoin conference, and that is in some ways a threat to Bitcoin. The ethos of Bitcoin being decentralized and counterculture and everything is where its strength comes from. And so the suits are a threat. Relatedly, but not the same thing, we have centralization as a threat. The ETFs and MicroStrategy, or now Strategy, and other factors are pulling a lot of Bitcoin into centralized repositories. And when there was a threat to Bitcoin from the block size wars, when there were companies trying to change Bitcoin, what defeated that was decentralized market action, people selling against it. And if all the coins are sitting in Strategy and ETFs, the only people that can sell against a fork are BlackRock and Michael Saylor. So that's a threat. And maybe we should be thinking about that as how do we maintain the counterculture against that? Is there anything we can do with consensus changes that make us stronger there? Another maybe emerging threat, I don't know that it is an emerging threat, but it's something worth talking about perhaps, is the failure of relay policy. Until recently, I think there was some truth, and this is where there was a bit of a conflict maybe between Buck and Shinobi earlier. There was some truth that relay policy was a meaningful control that Bitcoin Core as the primary implementation used to influence behavior on the network. And now, starting kind of last year or maybe the year before, it's been demonstrated intentionally by some folks who are here at this conference, myself included, that relay policy is ineffective. And by demonstrating it, that made it true, right? People respected relay policy because they used to think it was hard to break it. But now that everyone knows who cares that it's easy to break relay policy, it is now a failed control. So is that a threat to Bitcoin? Does that affect how we upgrade Bitcoin in the future? Can we not even use relay policy to protect future upgrade hooks? Does that mean we're going to be doing hard forks instead of soft forks in the future? These are questions. These are threats. These are things that have changed since the last time we did a soft fork on Bitcoin. And lastly, we have at least one new hostile fork happening this year, which is also something we haven't had in a while, and I'm happy to see it happening. And I'll get to why I'm happy about it a bit later in this talk. But yeah, hostile forks are threats, and they could change how we relate to Bitcoin. If a hostile fork has significant strength and hash power behind it, that could affect the way Lightning nodes respond. It could affect the way we open and close channels. It could affect the way we interact with our exchanges or accept Bitcoin on our nodes. There's things that happen when you have hostile forks in motion. So there is a changing landscape. We can't just be sitting on our laurels. And I hope that these threats kind of have the effect of threats. Another thing that's changed in terms of breaking ossification is that more than I think ever before, we have a lot of good options out there for potential ways we could change Bitcoin. These things have been brewing in the background for a long time. And in that time, people have started experimenting with them and figuring out how these things would work in practice. How would wallets adopt these things? How would they affect exchange interactions? All these different pieces have been being worked on. And this is not an exhaustive list or anything like that. It's just some things that are out there that are being actively thought about, developed, and could be how we change Bitcoin. And it's nice to have good options. Like BIP360 has a lot of support as an example out of this. The Fix soft fork seems to have a lot of support behind it. I was joking with Ekram before about whether Obcat does or does not. But there's things that are active, and that's very nice to see. And I think it's part of the steps towards kind of overcoming that inertia of ossification is being able to between good things and decide which of these good things is the right thing to do in Bitcoin. And I have a couple post-quantum things in here, if quantum is your thing. So the next thing I want to talk about here is where I said hostile forks are good for Bitcoin. I think we really need to, as a culture, we need to embrace forks and embrace chain splits. We got real scared about this, and this is some of the trauma we have from the block size wars, and it's okay. Bitcoin, it's okay for there to be forks. It's okay for there to be chain splits. They're not that scary. Here's the thing. This is an open entry network, and anybody can run any software they want on their node at any time. Shinobi personally has done this. He lost a little Bitcoin because he did this. But you can start enforcing new soft fork rules today. And you know what's funny about that? There's a decent chance that if you do that, you don't tell everyone about it. You get to use your Bitcoin that way, right? I could go start enforcing opctv on my node tomorrow and use it in TapScript where it's not visible on the chain, and I could probably even spend from it, and I probably wouldn't lose my Bitcoin, unless it's a lot of Bitcoin. It's an open access network. Anybody can run whatever soft fork consensus rules they want on the network tomorrow. Try it out. Have fun. Don't be Shinobi. You lose Bitcoin that way. Yeah, right. Don't go full retard is the key to doing that. But I think it's important to think about that. Bitcoin is just software. It's software you run on your node to enforce your rules for your money. And if you want to enforce stricter rules on your node, that's a soft fork. And you can do that and still participate in the network with the rest of the people. It only becomes a problem if someone else enforces conflicting rules to yours at the same time. Okay, so soft forks don't matter. You can run whatever soft fork you want, whenever you want. And it only matters if it becomes widely used and widely enforced. And if it does, well, that almost by definition means the market has made a choice, and that's the most valuable form of Bitcoin, the one that has that soft fork rule. And now it becomes useful to more people, and that's great. And if nobody else enforces it except you, and you don't put a lot of Bitcoin in it, then it has no impact on anybody else in the network. Right? So soft forks just don't matter. And then on the similar side, hard forks also don't matter. If someone wants to propose a hard fork, and it, let's say, invalidates, I don't know, whatever. Let's say it expands the block size. What's that? Oh, yeah, let's do tail emissions. Where's Peter Todd? So let's do a hard fork to start having tail emissions. We reclaim certain coins, or we add additional coins. You know, the new limit is infinite, and we just do tail emissions. That's a hard fork, right? Well, he can go run that, and all I know is that my node's never going to accept blocks that have tail emissions that create greater supply than 21 million. Well, not exactly, right? And it doesn't matter. It doesn't matter if he runs a hard fork client. He just forks himself onto a separate network. He either has hash rate or he doesn't. It doesn't matter to me. If everybody starts enforcing a hard fork and miners have to follow it, then almost by definition, that is the most valuable Bitcoin, and that is Bitcoin. And then I can choose to join that network. My keys are still going to be valid on that network. But again, it doesn't matter. There's nothing scary about this happening. Either, in a hard fork situation, either the existing rules are the real Bitcoin, in which case that's going to have the most economic weight behind it, and I'm going to stick with that, and it's great. Or the hard fork is going to have the most economic power, and that's where the money's going to be, and I'll have keys on that. None of this is scary. We don't have to worry about hard forks. We don't have to worry about soft forks. We don't have to worry about chain splits. And there's this weird reaction, and I got it, I'm not going to name names here, but from several prominent developers in Bitcoin, as though if we start having regular chain splits in Bitcoin, it's going to destroy the network. That's obviously not true. Bitcoin is specifically designed to withstand people running other software. It's a consensus network, which means everybody that's running compatible software will be on the same network, and if you're not, you'll be on a different network. And everybody, it's an open entry network, so everybody gets to pick on which network they participate at any given time. This is freedom. And if we act like acting out of freedom and forking the network is an attack, we're kind of almost undermining the very principle of open entry decentralization that Bitcoin is founded on. So embrace forks, embrace chain splits. Run something different on your node. See what happens. Break yourself for a while. The great thing is that your keys will still work on the old network when you come back later. It's okay. And this goes to the point of hostile forks are good. I want there to be more things like BIP 110 out there because they let us see this in action. And it's happening right now with BIP 110. Frankly, and I've said this before on other media, I wish BIP 110 was a better soft fork. I wish they had done something that wasn't so freaking stupid, because if they had, we would see a real market reaction, right? We would see a futures market pop up, and we would, like, Rob tried his damn best to get a futures market started, but it didn't work because it's just too stupid to do it. So I really wish they'd made a better attempt at a soft fork that was worth fighting, so we'd have a futures market. And then we would see that it doesn't matter. It's okay for there to be soft forks, and we'll see in the market whether this change or that change is the way to go. This is, I mean, Buck said this exactly. Like we have 16 version bits, I think it is. Is it 19? 15, okay. We have 15 forks at a time we could be doing. I want to see more of these. I want to see futures markets for them. I want to see us making... Yeah, I got something to do right now. Yeah, I want to see people doing these things and having futures markets because I don't know why some people hold this belief that these are dangerous things. Hostile software, they've been nipped in the bud. We can't let them start signaling. That'd be bad. No, it's good. We want people to be out there trying things, proposing to miners to signal for this or that change and seeing what happens, getting futures markets going. That's how we actually find out what the best Bitcoin is. Without that, we're just hoping that the rules we have right now are the best. We find out what the real best coin on the market is by having active participation in soft fork proposals and signaling bits going on all the time. Then the market can tell us what the most valuable thing is. Without that, we're just guessing. So, hostile forks are good. Forks are good, and even hostile forks are good. Well, what about second layers, though? And this is one of the directions I've heard about this from is, well, but second layer networks are going to be broken if we have a chain split. Lightning nodes aren't going to know which one to follow. They're going to lose people's money. Well, fix Lightning then. Bitcoin is an open access network where anyone can run any software they want and they can fork anytime they want. Lightning nodes should understand that, and they should be designed to take specific actions in response to certain kinds of events on the network. We have tools out there like Fork Monitor from BitMEX that tell us when forks might be happening, when there's even a one block split in the chain tip. And Lightning nodes can and should respond to those kinds of events on the network. If you're running a big Lightning infrastructure, you should have several different nodes in the network with different perspectives to know when there's even going to be a one block split so that you can respond appropriately and delay payments or delay responding to, let's say, on-chain actions like splices if there's a thing going on where the network is acting weirdly. Layer 2s for Bitcoin have to be resilient to the fact that it's an open access network where people can do whatever the hell they want anytime they want. We can't just be like, as kind of the ivory tower of Bitcoin developers, oh, don't start soft forking, you might break Lightning if it's not a 100% consensus when it activates. That's not how this works. We can't just stop people from doing stuff. This is Bitcoin. People can do whatever they want whenever they want. And that's really all I got. Consensus is emergent. So there actually isn't ossification. We never ossified because you could change your node tomorrow. Anybody can. It's just it's all in your head. The ossification is purely psychological. So there we go.
So would you say Bitcoin is in a quantum state of being ossified and not ossified at the same time?
Yeah, actually, I think it's a perfect characterization. Yeah.
Yeah, that's right. And the one comment on the futures market, I think that's just something that, independent of the BIP 110 stuff, it's about actually letting the economic holders and the UTX holders of the network express this stuff. And I think sometimes when people talk about changes, they view it in a strict academic sense of, well, you'll just have the miners follow and signal, and then it goes live after the devs push the code. And that just, I think in all of these changes, that's like a very important factor, is that in these contentious splits, the only way that you can go directionally long to support a direction is to go into a futures market, because just holding Bitcoin means you're delta neutral,
right, you're neutral,
because you have your UTXOs on both sides of the chain. Yeah, I had to say something productive after the quantum joke.
Yeah, no, I agree, and it's important that we all kind of remember this, that Bitcoin, it's an economic system. The miners are going to hash on where they can get paid, and to get paid, the money has to be worth something, and so it does depend who's going to buy and sell what. So the futures markets are going to tell us what's the most valuable thing. In the absence of futures markets, again, we're just guessing, and I can't emphasize that enough. When developers, including myself, are out there, I think, personally, L-Enhance would be the best next change for Bitcoin. But I literally have no way of knowing that until it's put to the market.
Good segue to my question. When are you going to put it to the market then? Do you have an activation client?
So being frank and honest, I do think there is value in the, let's say, technical momentum on these things. And so I really like the Thix proposal as an alternative to L-Enhance, and the guys that are working on it, frankly, have more energy for it than I do right now. So I'm supportive of them, and I think there is going to be probably more news coming out of that camp fairly soon. They've done incredible work recently of getting their stuff kind of worked into mini-script, and I love kind of the direction they're going over there.
So speaking of momentum, my biggest fear is like BIP 110 will obviously fail, and then now since like a soft fork has failed, all future soft forks will be presumed failed as well, and we can just never activate anything again.
Yeah, I mean, these things can happen, and I think this is why to Rob's first question, like this is all in our minds, and I've noticed, myself included, like I'm not trying to throw stones here, that we get psychologically stuck in that mindset of oh, we can't do anything because it hasn't worked, and the reality is that that's almost a self-fulfilling prophecy, and if we decide that we can, and then we will, and that's I think where the future is actually going right now. The BIP 1 or the BIP 360 folks, I think, also have that mindset of this is where we are going, and so they have that almost deterministic optimism or whatever we're going to call it. And I think that's the way that we have to approach these things: is that the ossification's only in our minds, so we take control and we do the things. All right.
Thank you.
Thank you.
All right. So mempool policy is Bitcoin's administrative state. That is the claim I'm making with my talk. This is the enemies edition of Bitcoin++. So I guess I'm making the claim that the mempool is the enemy, or the developers that work on the mempool. That's mostly just tongue-in-cheek. But I do think that this is a problem worth exploring. I think a lot of the problems that we've heard about already so far in some of the previous talks about the things we might need in Bitcoin, or the way that we're arguing about things on Bitcoin, seems to be broken. And this is my attempt at understanding potentially why. So to start, ossification, this is kind of this key word in Bitcoin. You have the like pro-ossifiers and the anti-ossifiers, or the people that think we need to continue changing things. And so, typically we look at ossification from the perspective of, soft forks. Like, how many soft forks are we doing? How many new opcodes are we introducing? And if you're pro-ossification, the idea is like, okay, no more new opcodes, no more soft forks. That's the goal. But if you press on this question, when people that are pro-ossification, what they talk about is like, are we talking about no more development? Are we still going to be fixing bugs? Are we going to be introducing network optimizations? Are we going to be improving network bandwidth or what have you? There's a no, of course not. We're still going to have development. It's just no more soft forks, and nothing that like changes the mechanics of the network. But as we've seen in recent development debates and conversations, like the network dynamics have still been changing, even though we haven't been having soft forks. So development has continued that impact how we use Bitcoin. It's just not at the soft fork layer. And my claim is, this is a dirty word in Bitcoin as well, this idea of governance. And I think the reason why people have a lot of difficulty with the word is we imagine some centralized force that is making decisions, that's publishing a roadmap and saying what will be next in Bitcoin. I don't think that's what governance is. Governance, for me, is basically just how large groups of people make decisions amongst each other. And it's always going to happen once you kind of like scale groups of people. It just will manifest in different ways. This image here, the reason why I selected it, it's about the parable of Chesterton's fence. And the idea with this is that the idea is if you have two reformers that are walking in a field and they see a fence that doesn't seem to be doing anything, is like decoupled from any sort of purpose, the more kind of progressive-minded reformer will look at it and say, well, it's obviously not doing anything, so let's get rid of it. And the other, perhaps you could call a more conservative reformer, will say, well, if you don't know what this was for, then you shouldn't get rid of it. Understand what it's for before you start talking about getting rid of it. And so I'm making this claim about governance, and even like soft forks and just like our decision-making process. Before we throw everything out that had been working for us, let's understand what its purpose was for, how it was meant to operate, and what the consequences might be of taking it out.
And what I think is worth kind of considering is that you can't really get rid of governance, as I said, right? So if you get rid of the decision-making processes, all that ends up happening is that the decision-making goes elsewhere. And it might manifest in ways that we don't actually really like, that might not be good for Bitcoin in the long run, right? We're not talking about specific changes here. We're talking about the process by which we decide to make changes. And so the reason why I'm making this comparison with the administrative state is I think it's something that most people in the Bitcoin ecosystem in general are probably not happy with. We don't like the way that governments have manifested. But also I think it's the idea that human nature is constant, that we deep down are still these hairless apes that operate in a certain way, and that we will operate in that way no matter what. It's just the context changes. And so I'm making this comparison because I think we've seen a lot of things in kind of the evolution of Western democracies that we don't like, and I think we should consider that maybe that is it's been happening as a result of kind of like what we've kind of like opted into, and that we should learn from these mistakes before making them again in Bitcoin, because again, governance is happening whether we want to admit it or not. So before I go into like historical comparisons in terms of like how these things developed, I wanted to kind of walk through a few kind of like concrete comparisons, I guess, in how I think these things parallel. So first, I think what we see in both the administrative state and mempool policy is that these are ways to kind of circumvent the normal means by which change would otherwise be happening. The other thing that happens as a result of that is you kind of get a lot less transparency, that the typical means of making decisions and instituting change in, say, for example, the US government, as well as in Bitcoin, was more of these like transparent, like really big coordination problems amongst large groups of diverse stakeholders. And if you don't use those means, changes still happen, but they move into less transparent areas. Next, we have omnibus. What happens is we've seen like Taproot was not just this like one change. It ended up having a lot of other things that came in with it that some people didn't like, but they didn't realize what was going on. The other concern is also that if you don't do things when you have the space to talk about it, change then typically will only happen during big emergencies, right? So think about like post 9/11, right? And I've heard this claim for certain soft fork discussions like, well, what's the emergency? Why do we need this now? Like nobody's complaining about this or that. It's like, okay, if we wait until it is an emergency, we might not like the result of that because you end up rushing things and making bad choices. I think I need to, there we go. Another thing is you get this parallel of complexity. When you move around the typical means of making change, you end up having systems that kind of like have to find these, find the loopholes or find ways around the normal ways of operating. That introduces a lot of complexity. But the thing with complexity is not only is it just harder to understand, like this saying that complexity is a subsidy. When you make things more complex, it benefits the people that understand that complexity or can afford the people that understand that complexity. And that makes things less accessible to new people to come in, and it benefits the people that have easier access to that expertise. And the last thing is, as a result of a lot of all of this, what you end up having is that it also benefits, well, first, the way you advocate for change is not through normal means like signaling, for example, like we have in Bitcoin, or for voting like we have in kind of like a representative system. It ends up moving into like if you have the lawyers, or honestly, it's also like just mob rule. Do you have the largest rally or the biggest protest? Is your group making the most noise on Twitter? This might sound familiar to some of us in this room. And that's just because like our channels for actually feeling represented, like we have an impact, have just been totally undermined and in some cases disappeared altogether. So we'll go a little bit history now. Like the idea with the American Republic is it was designed with a system of checks and balances, right? The idea being that you have originally from Montesquieu in the 17th century, French political philosopher, that the best way to ensure freedom, not to guarantee it, but to help protect it, is through systems of checks and balances where you have different interests that can counter each other. And so in the US system, that manifested as first the federal versus the state governments and the individual as well. And then within the federal government itself, you also have the legislature, the Article 1 branch, the most important, that is supposed to make the rules, the executive branch that is only supposed to be executing on the rules, and then the judicial branch that is supposed to be judging the legality of those rules as proposed and as implemented.
And we have various means for those to manifest, and what we see is kind of like as those traditional systems have degraded over time, so has our ability to basically be represented and have effective rulemaking. So this is a chart of the constitutional amendments as they've been proposed. I have a few kind of like milestones that I'm including here, because as we'll see as we go through the charts, our representation kind of starts to go down after these milestones. So at the beginning we had the 17th Amendment, which was the direct election of senators, a popular election rather than elected by the states. We had the establishment of the Federal Reserve basically in the same year. In 1929 we had the Apportionment Act that basically froze the House of Representatives, which up until that time always grew with the population of the United States. By freezing it in time, we actually diluted out the representation of the people in the federal government. And then the end of the gold standard. And that freezing of the House is, I think, a really important one that I don't think gets discussed enough, because this is really where we start to see the relationship between government and the people changing. So we had fewer constitutional amendments. Another kind of representation of these checks and balances operating would be vetoes, right? If the different branches are in tension, the veto was a way to kind of represent those tensions. The president's job was also to not just veto legislation that they don't like, but it was also to veto legislation that they thought was unconstitutional. And you can see that we had basically a decrease in vetoes, certainly after the end of the gold standard, but it really started at the beginning of the 20th century. I think another kind of manifestation of the checks and balances is also overriding of the vetoes. The percentages probably don't do the best job in showing this number going down, because the number of overall vetoes started going down as well. But to override a veto, you need a supermajority of Congress, and that of course requires both parties, and that's really what you want. You don't want the president of one party agreeing with 100% of the representatives of that party in Congress as well, because it's the branches that are supposed to be in disagreement. Now, this one I think is really striking. We start to see that the laws passed by Congress starts to go down in the second half of the 20th century. But what's worse and scarier about that is you might say like, oh, well, this is like less rules. That's great. Good. The government's staying out of our way. That's not true if the pages per law starts to go up. So we have fewer laws, but the complexity, remember we were talking about that before, the complexity of those laws starts to increase dramatically. And of course, the agencies. So you can see up until the beginning of the 20th century, we had very few administrative agencies at the federal government that were being created, and all of a sudden this starts to explode, especially after the establishment or the locking in of the number of state representatives. This is where we handed over legislating control from the legislature over to the executive branch, essentially. Executive orders was another way in which this manifested. This is the new way in which we make rules through the administrative state rather than through legislating, and kind of that open debate. Okay, why am I talking about the American government, American history, and the breakdown of that? Well, I think that we are seeing a lot of the same parallels in Bitcoin today. This idea of ossification is that Bitcoin was designed to be hard to change because it shouldn't change. And my argument is that that's not true, that we are meant to be able to change Bitcoin. It just needs to be really, really hard. The reason for that is you don't want to make a mistake, of course, and you want to have everybody involved in making those decisions. And of course, we have many means through change, to make change, right? Just like in the US, like at the federal system, the Constitution, this is the rules that we all agree to live by. But at your local level, you can also make your own changes. I think the same thing is here of making changes at different layers. But you want to do this in a way that doesn't impact everyone as well, and doesn't circumvent kind of like the normal decision-making processes that are more transparent. My opinion, the purpose of the difficulty of changing consensus is that it requires coordination. It requires collaboration. It's not to say it shouldn't be done, but if you think of consensus as being like the constitution of the Bitcoin ecosystem, it's everybody needs to agree before we move forward, right? Consensus is basically the rules of what we accept in a block. And if we don't agree on what those rules are, even if we don't necessarily like them, right? You might lose. You might be wrong about something, but you have to agree like, fine, these are going to be the rules that go into place. If you don't, you just get forked off. It's a new network. And so that coordination is a really important part of why it's difficult. But the other reason is like you have to talk to all the stakeholders. You have to get them all on board, which is a really important part of having a free society, I would argue. Mempool policy are the rules that a node is kind of is deciding how they accept transactions to broadcast. It is not the rules that we all agree to live by, but as such, the design decisions around mempool policy are very different from around consensus, right? It's not the blocks that we all have to accept. It's really about kind of efficiency and protection of the individual nodes, right? At the end of the day, if you don't relay a transaction, but enough of the network does, it gets into a block, you have to accept that block. So policy is opt-in. That's how we think about it. That's why we say, like, oh, this is safer. But the reality is that the whole network can end up being impacted by it, even if you don't have a majority of nodes that are signaling. Defaults are really important as a result of this. And so that's kind of how we see we see this as well, like the regulatory level as well, right? Like our legislation might have included something about creating an agency, and then that legislation just says shall protect our environment, and then they can just decide what that means, and we have no recourse, we have no accountability, we can't vote them out anymore. That is now law, and that's similar with policy in a certain extent. These things can be changed without any predictability or involvement from the greater ecosystem. And we've seen this, right? So this is a timeline of soft forks from 2009 to 2021. I think importantly, we haven't had a soft fork that wasn't basically designed by Peter Willa for over a decade. And you can see that these gaps started to get larger. But change continued to happen over that course of the decade. It just shifted elsewhere. The debates were happening elsewhere. And of course, sometimes those debates would erupt out into the public, and all of a sudden the public was like, wait, what are you doing to my Bitcoin network? It's because they didn't have to have a voice, because you can just put these things in. So a lot of these changes, I got the dates for this chart, and then a lot of these diagrams from a recent post that InstaGibbs from Spiral wrote about the development that we had in the mempool policy. And this is a really, really tricky problem that they had to solve. A lot of it is related to L2s, and again, like layer 2s, this is about this complexity where, the closer you are to the regulators, the more benefits you get in terms of like getting your special rules in. We have a lot of challenges with layer 2s because a lot of them depend on pre-signed transactions. What are the challenges with pre-signed transactions? We actually heard about this in the previous talk, is you're pre-committing to inputs and outputs when you're signing it, and that means in Bitcoin that you're also committing to fees. What happens when you're pre-committing to fees in a pre-signed transaction that is enforcing something potentially in the future? You have no idea what the fee market is going to look like in the future. So this means we have to come up with a bunch of workarounds, of carve-outs to allow those transactions to get fee bumped, to get broadcast, to get relayed. And this turns out to be a really hard problem if you're doing it at the policy layer. So pinning attacks are ways that, and the other thing with layer 2s is they tend to be multi-party protocols, right? So you don't know if the other person that is in this channel, for example, with you, is potentially a malicious actor. So that could impact your penalty mechanism, for example. And that's what a pinning attack is when you're trying to publish like a Lightning transaction. If you can't fee bump because it's pinned, CPFP carve out. Again, remember I was talking about if when you move more to kind of like a regulatory state, if you have access to the regulators, to the experts, your preferences get put in. We needed CPFP carve out to help with fee bumping and Lightning. We get this carve out to get put in. And again, it's not simple, and we've been trying to iterate on this problem for years now. And then just like generally the complexity of this problem, if you look at the amount of words that have been written about package relay and how to solve this problem over the past decade, it's like hundreds of thousands. It's incredibly complex. I know a lot of the bit devs around the country have been talking about this forever, and most people don't know what's going on. They don't understand the problem. They don't understand how to solve it. They don't understand these things that are being pushed forward. This also kind of leads to the bike shedding effect, right? It's like this package relay thing is way too complicated, but spam on Bitcoin, I totally understand. And then that's the outlet for all of our frustrations. And like even by the admission of this blog post itself, like this was just like really crazy shit that we were trying to solve and constantly iterating. In fact, sometimes like kind of like overriding previous attempts to solve this problem. As for example, we have a much better solution now with cluster mempool that helps with some of it, but not 100%. To me, the craziest thing, and I think worth noting in terms of the point I'm trying to make here, is that for this particular problem, there have been soft forks that have been proposed, new opcodes that could help solve this problem. So the top one that comes to mind is transaction sponsorships. This is basically a way of encoding in consensus package relay. It is much simpler to understand all of these network dynamics about how to mempool, because you don't have to solve for the like DOS protections and the pinning attacks. There's still some issues to resolve, but it's still mainly just at the mempool, and it simplifies those situations. But why do we not talk about it? We're ossified. We're not going to make any more changes. But it's like, we're still making changes for the same problem. They just shifted elsewhere, and nobody knew what was going on. And we didn't have a chance to vote on it. Like, maybe those things would have been preferable. Maybe transaction sponsorships would have been preferable to some of these package relay, but we didn't really have a chance to vote on it, so to speak. And I think this is a common refrain with this topic, is that policy changes have less risk because they're easier to roll out. Great, and we can roll them back too, right? And then soft forks, we have to always maintain them. Thing is like with opcodes, you can kind of opt out. If you don't want to use it, you don't have to use it. If you have protocols that are dependent on it, you can kind of roll off of them. You know what's in there, and you know if that if they would be deactivated in some way, you would know that that's coming as well. What we've seen with some of the mempool debates is that sometimes changes can be put into place that impact existing business and users, and those changes can come out in a way that are a surprise. Now, whatever your feelings on full RBF versus opt-in RBF, we had a system that was in a BIP that was adhered to by most of the network that businesses started building upon under that assumption. Yes, there were risks, but they built that into their business. And then all of a sudden, there's a new release being cut that says oh, we're going to change that. Now, maybe that was the right change to make, but again, there was less involvement of the community. And I think if we were to put let's put it in terms that are maybe a little bit less, controversial. Imagine some of these package relays changes go in, and a bunch of Lightning transactions are pre-signed and ready to go. And then maybe 5 years, who knows who's maintaining Bitcoin at that time? We get a policy change that goes out that basically makes that those transactions can't be broadcast anymore. That can just happen. We don't have to talk about it. We don't have to debate on it. There's no transparency about when is this going to be activated because of miner signaling or anything like that. It just happens, and it breaks people's Lightning channels. What I want to be clear about is I'm not saying that these changes that went into the mempool policy or that the soft forks that I've mentioned are that those are the ends that we should be aiming for. What I'm talking about is the means. We are not taking control of the protocol as an ecosystem, as a community, by abdicating the responsibility for debate, right? BIP 9 made it so that we could have up to 15 simultaneous soft forks being proposed at the same time. That is a lot of transparency. The system was meant to be changed, just it would be very hard to change. And we have only had 2 that have been even proposed for activation since 2016. That is far fewer than the slots that we can have at any given time. And as a result, people don't know what's going on. The debates come as a surprise. And the other problem that ends up happening as a result of those debates being a surprise is that people feel that the only way that they can end up feeling represented, like they have a voice, is basically through mob rule, right? It ends up being okay, my crowd is the loudest. I got the most likes and retweets on Twitter, right? We have the biggest rally or the largest protest, and all of a sudden that adds legitimacy to your side. Now, not only is that objectively wrong, that is not a way to measure legitimacy or intellectual rigor of a particular position, but it's also not a good way for us to come up with good decisions, because then you end up having to debate straw men instead of having real debates about the consequences, because straw men come as a result of just trying to be as loud as possible. You want to have the quickest argument to mind rather than the best argument. At the end of the day, we want Bitcoin to be anti-fragile. The only way Bitcoin as a network, as a protocol, is going to be anti-fragile is if our decision-making process is anti-fragile. We have to be smarter. We have to be more rigorous. We have to challenge ourselves. We also have to be willing to lose, right? Free societies with large groups of people, you cannot have 100% of everybody agreeing all the time. That means there will always be a subset of sides that lose. You want that in a free society. Right? The alternative is basically violence, or everything splits up to a point where you don't have, the world's best money. You just have the best money for your individual group, and at that point, we're no better than an ICO. So really what we want is persuasion, compromise, being okay to lose, not coercion that forces people to go along with you, however you might accomplish that coercion. Thank you. Okay. Great. So the timer didn't go back on, so I didn't know if I was over or not. Okay. Okay.
What would you say to the assertion that your entire framing is fundamentally flawed and there is no decision-making process here? That the most liberal, permissive relay policy enforced by even a tiny rounding error minority de facto sets that state, and everyone else simply has the choice of engage with the network in a degraded functionality or not, but they have no involvement in deciding what policy is?
I would say that that's exactly the framing that I made, basically. So my point is that decision making happens one way or another. It's the means by which that decision making happens. And so if we allow ourselves to, if we abdicate the responsibility of kind of like voting for changes and upgrades, it moves into that place, as you're talking about with mempool, where we're not as involved. And so it should be, I agree, it should be as permissive as possible. But the problem is like people still want change, right? People still need to fix things with Lightning, for example, or for Citria, or whatever the case might be. And so as a result, we don't get the mempool that we should have, which is as permissive as possible, because we're trying to represent something that should be represented at the consensus layer being represented at the policy layer. And then you don't need as much buy-in to get those changes in place because you only need a small minority that are signaling or involved.
I mean, that's kind of where I see like a flaw in your framing, is like looking at things homogeneously. Like that subset of more permissive players is all you need for a functional mempool. Like we have that permissive policy right now simply because that minority exists operating in that mode.
Yeah, I mean, I just don't see that. I mean, I still see, again, we've seen a lot of developments that are happening in the mempool. If my framing was incorrect, we wouldn't be seeing as much activity on mempool on policy changes, and we also wouldn't see so much upset on policy changes. We would be seeing them more at the consensus layer, which you want, because that is where we actually it's the more participatory layer of the decision making. And so the idea that we don't have governance is obviously flawed because we're all making decisions all the time, and there are people that make decisions that impact all of us all the time, and that has been happening in Bitcoin for over a decade now.
It's interesting the way you're framing this. I would say this is an area where the Bitcoin Cash fork, I think they very emphatically agree with you that you want to have active buy-in on changes to the network, and that's the reason they continue to make hard forks instead of even soft fork changes. What do you think about kind of that difference between soft forks versus hard forks as well?
I mean, I see a hard fork as basically like the equivalent of a civil war, right? And that ultimately it can't survive on its own because, you know, there's this whole thing like live by the hard fork, die by the hard fork. And like actually for like a strong system that can be as inclusive as many people as possible, you need to have that ability for compromise. It also means being okay losing. Like I think the thing that turned me against Bitcoin Cash most of all, or like thinking that their approach was flawed beyond just the size of the blocks, was they had to change the difficulty adjustment algorithm, because that difficulty adjustment is like it has to be very expensive to be on the losing side. And if you change that, it's like you're changing the governing mechanisms. And because they did that, it became way easier for other like internal conflicts to break that community apart. And so ultimately what you want to do is like make the argument, see if enough of the community is on board with you, whether it's the miners who need to make as much money as possible, the nodes that need to scale that system as well as possible, et cetera, the businesses that need to build on top of it. And if you get everybody on board, you're not hard forking, you're soft forking. So you want to have a system that like changes things, that has disagreement, that has some losers and some winners, but in a way that kind of like keeps everyone together as much as possible. And you do that by making it really expensive. That's why like the US does not have the same thing that the EU has, which made it possible and easy for Brexit to happen. You're not allowed to leave the union. And that's basically what Lincoln found out. I was like, no, you've got to convince people that you're right. And the South was wrong.
All right, thanks for hanging in there, everybody. Lots of technical details. So my name's Kyle, Kyle Olney. I'm a senior advisor at the Bitcoin Policy Institute, and I'm here today to talk to you guys about the coming era of nation-state hash wars and the implications for the Bitcoin network. So, we don't have the windows open right now, but, you guys are sitting inside the Hoover Dam, which is one of the largest hydroelectric facilities on Earth. And believe it or not, this facility itself is actually the physical embodiment of the problem that I'm here to talk to you about today. So over the course of this talk, I'm going to walk you through a thesis that I think should concern every Bitcoiner, both in this room and around the world. And I believe that the great powers are about to come to the realization that they're sitting on literal oceans of free hash rate. And when they do, Bitcoin's security model is going to face its greatest challenge that it's ever faced. So just as some, kind of like basics about this facility, for those of you who already went on the tour, you'll maybe have a little bit better idea. But this facility produces it's rated at 2 gigawatts of power output, and it produces about 4 terawatt hours per year, which is functionally the equivalent of about 3% of the Bitcoin network's entire hash rate. And I want you to keep that in mind as we go through this, but I'm going to throw a lot of numbers at you, so don't feel like you need to follow them entirely. Just relative Fermi scale is all you really need. So let's zoom out for a second. From this specific dam, these are all the hydropower dams that are located all around the United States. As many of you will be aware, we're very blessed with our geographic assets in the United States. There's all kinds of stuff here. And basically, we have lots of hydropower among other things that we have lots of. But for now, obviously, we'll just focus on kind of like hydropower, and we'll get into some other stuff later. Given that we have all of this hydropower in the United States, the U.S. Army Corps of Engineers manages a portfolio of about 75 facilities that have a generation capacity of about 20 gigawatts of energy, which means that it produces somewhere between 80 and 100 terawatt hours per year. And that annual generation is about 50% of the entire Bitcoin network's hash rate, which hopefully is starting to, flash your spidey sense on kind of the scale of assets that the United States government has. And then to talk again a little bit more detail about the market sizing comparison here, 100% of Bitcoin hash rate at the moment is somewhere around 200 terawatt hours a year. Obviously, this fluctuates depending on the difficulty and various other things, but in general, that's about the best number that we've got right now. And the U.S. commercial mining sector is somewhere between 60 and 80 terawatt hours a year, which is about a little more than a third of the global network. So the U.S. Army Corps of Engineers hydro portfolio alone, just the hydro portfolio, is already 25% larger than the entire United States commercial mining fleet. And it's about half the size of the global hash rate. And in case you think I just cherry picked the Hoover Dam because we're sitting in here and that this is super big, I'll zoom out a little bit more. This is a picture of the Grand Coulee Dam, which is in the Pacific Northwest. It was built during the Great Depression, and it has a 7 gigawatt generation capacity, which translates to about 20 terawatt hours a year, which means that single facility that the United States government operates could power 5 to 10% of the Bitcoin network's needed hash rate on a yearly basis. Okay, but here's the twist, right? A lot of the power that's generated, and in fact, way more than the power that's generated just at this facility, gets thrown away every single year by the United States. And that's because we don't have transmission interconnects, we don't have battery infrastructure, there are all kinds of distribution and delivery problems that exist. And so basically, we end up lighting all of this money on fire, or all of these jewels on fire, right? We just literally do nothing with them. We spill them on the floor, we run them over the spillways here at the dam, in all of these various ways, we basically just literally light these jewels of energy on fire, and we get nothing for the benefit. And so, naturally, you're probably wondering, okay, that's maybe an issue, but it's not just dams, right? We have all kinds of renewable and dense energy assets in the United States. So this is a picture of Edwards Air Force Base down in Southern California. As some of you may be familiar, this is one of the largest air bases in the entire country. It has almost a 1 gigawatt solar array that's connected to it with about 3.5 gigawatts of battery storage that are attached. So it generates 25 times the amount of energy that it needs to maintain itself for the base. And it actually sells the overflow energy back to the surrounding community in Southern California, and that's about $100 million a year for the government for the benefit or the privilege. And this has been such a successful program for the US government that they're actually wanting to stamp these down at every airbase in the entire United States now because of a variety of different strategic reasons that I won't get into in this talk, but effectively you should assume that this is going to continue to happen all over the country. We also have an abundance of nuclear assets, obviously, in the United States. We have the largest nuclear fleet in the world with almost 100 gigawatts of installed capacity. Obviously, for the perspective of Bitcoin mining, nuclear is very powerful because it's got a 90% capacity factor and it's almost always on, which is clearly very helpful for mining. And then the same thing is true with geothermal. We have enormous geothermal assets in the United States, mostly undeveloped at this point. But again, these operate 24/7, 365, really large capacity factor. So they're exceptional for Bitcoin mining. So if you were to add up all of these things, the hydropower, the solar fields, the nuclear fields, and our geothermal assets, the United States is sitting on an enormous portfolio of energy. And every year, as I mentioned, we curtail large amounts of that energy. So somewhere between 20 and 40 terawatt hours ends up getting thrown away on a yearly basis, which is approximately $1 to $2 billion in wasted energy that we're, again, just throwing away on a yearly basis, which if you convert that into Bitcoin at current market prices is somewhere between 15 and 25,000 Bitcoin per year. It's also worth mentioning that this is the curtailment is going up on a year-over-year basis, and so we're continuing to break records, and basically there's no stopping this train. It's going to continue to increase forevermore. And again here, I'll just show you for the scale of US energy assets, the Bitcoin network is quite small. And then inside the larger Bitcoin network, you have the US slice, which is about a third. And then of that 1/3 slice of the Bitcoin network, if you mapped the curtailed energy that the United States currently throws away onto this, you would see that it's a sizable portion of the current network. So the US government alone controls an existing energy portfolio that it dwarfs the scale of the Bitcoin network and a lot of the demand that would be out there for hash. And its marginal cost of production is effectively zero, which here again should maybe start throwing some alarm bells off in your head, because this really, really changes the game theory that we understand about Bitcoin and how the network operates and secures itself. If you happen to have an energy portfolio this large, this cheap, this underutilized, and as an entity you begin to start mining Bitcoin, what do you think that's going to do to the network? Well, on the commercial side, I would argue this is a practical inversion of everything that we currently understand about Bitcoin. The best private miners in the world today get somewhere between 2 and 5 cents per kilowatt hour for their generation. That's an exceptional price, by the way. You're probably paying multiples of that at home, wherever you live in the country. And so, 2 to 5 cents is not nothing, but compared to zero or negative pricing, which is what the US government has, that is a really strong inversion of market dynamics. And effectively what that means is that no private company can compete long-term against the United States government if the US government decides to become a large hashing entity in the outside world, which, basically means that, you're falling into a gravity well, right? When it comes to Bitcoin mining and nation state hashing. The logic is kind of inescapable. Once nation states get into this game and they realize that they can get into it because they have structural advantages relative to every private market participant, the economic incentives and security of the network, I think, are going to get turned upside down because, again, why wouldn't you do this? If you're throwing away billions of dollars in Bitcoin a year just because you didn't plug in some Bitcoin miners at the state level, how long do you think that problem is going to continue to persist? Right? Just rationally. So this is kind of the point where, you break out the good tinfoil and you might be wondering like, okay, but like, not sure how bad this problem really is, or do I really need to worry about it? Is the government actually moving toward making such moves? Well, I would argue that yes, we're already seeing undeniable policy signals from the US government. We had the strategic Bitcoin reserve executive order from last year, which also contained agency directives to every federal government agency to identify budget neutral acquisition methods for adding Bitcoin to the strategic reserve. And again, the US government, just by creating the reserve and then holding, what is currently about $25 billion worth of Bitcoin, I would argue is a very interested party in this area and will continue to do it. And of course, what is the most budget neutral way that you could acquire Bitcoin? Well, you would just mine with the energy that you're already wasting. And you don't even have to wait to see whether or not this is a reality that's coming to us from the government side, because there's proofs of concept already out in the wild. So many people here will be familiar with the idea that down in El Salvador, they are trying to use their volcano geothermal energy to do domestic mining, and they're stacking as much as they can down there, issuing volcano bonds to build out more of those assets. People will be less familiar, but another very strong example of this is the Kingdom of Bhutan. They have really substantial hydropower assets that they've been utilizing for years now, and it's allowed them to build a really sizable stack of Bitcoin, and they are actually the largest per capita Bitcoin holding country in the world, and it's materially inflected their personal financial resources inside the country and made a huge difference for the quality of life for their people. So again, and I would say that the hash rate genie is kind of already out of the bottle when it comes to nation states and how this market is going to develop, which leads us to my belief that we are entering the great hash power competition, or the era of great hash power competition. And, again, you might think, okay, well, inevitable, this is going to happen. But, the thing that's really challenging about this from a Bitcoin perspective, and then also from a US Bitcoin perspective, is we are not the only global power who is sitting on literal oceans of stranded energy. China is currently, without doubt, the world's dominant energy superpower. And this is something that clearly the US government is aware of, but I would argue is not making nearly enough progress on. China is really a hydropower monster. So they've got about 440 gigawatts of hydro capacity, which is 4 times the entire US total. They've got a 20 times larger portfolio than the US Army Corps of Engineers portfolio, and they curtail somewhere north of 60 terawatt hours a year, which is literally the entire US commercial mining fleet. So they literally just throw away more energy on a yearly basis in China, just in their hydro power portfolio, than the entire United States mining industry points at hashing for Bitcoin. And of course, China is also a solar juggernaut. They're almost a global monopolist in this area at this point, and they're continuing to scale materially. So here you can see the graph. This is the difference between the Chinese power industry and the United States power industry. Last year, China added 500 gigawatts of new capacity in 1 year. So that 500 gigawatts they added just last year is larger than the entire US grid installed in the year 2000, even in the year 2005, almost up until 2010. They're probably going to create more, or they're going to add more generation capacity just this year in China than we had in entirety in the United States in the year 2010, which is incredible. It's insane. And they're adding at a rate that's 10 times the rate that we're adding here in the United States. So this year will be a record-breaking year in the United States. We'll add somewhere between 50 and 80 gigawatts. The Chinese are expected to add somewhere north of 750 gigawatts this year. So again, this should kind of scare you. And again, for comparison, you see here, this is just their curtailed energy in China. So they went from 65 in 2024 to almost 100 in 2025, which means that 2 years ago, the Chinese curtailment was larger than US Bitcoin in mining. And by next year, China's curtailment will probably be the size of the entire Bitcoin network, or in the neighborhood of the entire Bitcoin network. And then clearly there's another important twist here, which is that at least as it relates to China, there's incredible hardware vulnerabilities, right? China is responsible, and Bitmain is responsible for producing 97% of the top-end Bitcoin mining hardware that it's out there today. Clearly that's an enormous supply chain problem. This is very similar to a lot of other supply chain problems that we have in the United States vis-a-vis China. But specifically as it relates to the Bitcoin network, this is a real existential risk when you add it up with the energy access that we were just talking about. So being able to have both the energy and the hardware infrastructure cornered makes things very scary from both a US Bitcoin perspective, and then I would argue for everybody in the Bitcoin network's perspective. And of course, China's not the only competitor with these assets, right? There are plenty of other people. I don't really have the time to go deeply into this, but needless to say, Russia, Brazil, India, Canada, whether they're aligned, unaligned, frenemies, you name it, there's all kinds of sovereign powers out there who have access to very similar resources. And this one cutout that I will show is just an example of Brazil. Brazil's not like really thought of as a major strategic competitor of the United States, but just look at the scale of how fast their curtailment is moving up the curve now in the last couple years. And you can get a sense that like, this is a problem that exists and it's starting to pop up in many places around the world and kind of affects the network. And so why is this really concerning? In my opinion, it's because the game theory that we have understood or relied upon in private commercial sort of contexts is just radically different when it comes to state actors because they have totally different motivations. I won't belabor this slide because you guys are all super familiar with it here, but I mean, effectively, the classical deterrence model on a 51% attack assumes an economically rational actor, right? Well, states are rational actors, but their sort of value function is not economic, right? It's power and control. And so the reality is that if it is in China or some other power's interest to crash the Bitcoin network because it represents an existential challenge to them, it represents free speech, whatever it is that they're against, it doesn't matter whether they have to light $10 billion of mining hardware on fire to do so, they will do so because they print their own local currency units and it all comes out in the wash anyway. It's just about their strategic power objectives. And again, here I'll skip over some of this, but let's just suffice to say there are a lot of reasons why governments would want to mine that are more than profit. It could be censorship and rearranging the blocks or censoring certain transactions. It could be silent accumulation in the network. You don't want to like announce that you're building a $100 billion or $200 billion position in Bitcoin until you do. You might want to use it as leverage over the network. So I think like China, for instance, could very easily just threaten to destroy the network, and that has consequences in the same way that nuclear deterrence does. And then you could just want to destabilize the network. You could just be a chaos agent. Like you might not really have any other objective other than just, hey, I don't like what's going on here and I want to blow it up. And so I would argue that the most dangerous scenario that we confront right now is that we could have one or many nation state hashing actors who are building up sizable percentages of hash rate quietly in the background, and we would be none the wiser. And it's actually the most dangerous scenario is the one where you have somebody who pushes, actually this is kind of like the current Iran situation. They don't have a nuclear weapon yet, but they're so close to being able to reach and grab a nuclear weapon that it's threatening and dangerous, regardless of your feelings about what's going on in the Middle East right now. The same thing is true here, right? Like China or another adversarial actor doesn't need to get a 51% control over the hash rate. They just need to be within striking distance and then have the like feasible ability to extend and then take their attack. And then here's like really the thing that I want to pose to everybody in this room, right? As a thought piece and something that we all need to consider as Bitcoiners, like what are we going to do if and when this happens, right? Like in my opinion, it's kind of an inevitability given kind of what we're looking at, but we don't have a lot of prior art for 51% attacks other than, kind of very early ones, like there's Ghash and some other stuff that happened very early on in the network. We haven't seen anything serious in a long, long time. The solutions that existed back in the old days, or whenever we've seen a private commercial 51% attack threat, basically are off the table. Like social signaling, pool migrations, these are great. China's not going to do that because you asked them nicely. That leaves us with things that are basically non-trivial or kind of existential from a Bitcoin network perspective. We can either do things like hard-coded checkpoints to prevent block reorgs, or we can increase the cost to execute double spend attacks by extending confirmation times. These are probably like decent first, sort of responses, but they're not actually going to solve the problem of a motivated attacker like China actually deciding that this is important to them. And so that really kind of leaves us with some place that we never dare to go. And frankly, I think we need to start having some conversations around, which is what kind of consensus changes would be required in order to prevent nation state capture of the Bitcoin network. There are some ideas that I've thought through and I've talked to others about, but suffice it to say that they're all sacred cows that would, like the quantum debate, need to entail substantial internal community dialogue and sort of wrestling to come to a conclusion about what we feel is the best answer to what is an otherwise existential question, right? You can either have immutability, the way that we, like to believe that, Bitcoin should exist and can exist, or you might have to have the choice of survival, right? You just have to adapt. You have to change the consensus protocol. You have to do something, or you're going to get captured by a foreign hostile state. Or potentially, our own hostile state, right? If the United States had a different interest for the Bitcoin network than, we, the average users of the Bitcoin network, would have. And so the question is, at what point does defending the network from capture dictate consensus changes? I think that in general, there are some ideas here around like hash rate transparency, having formalized response frameworks, figuring out ways that we can diversify the ASIC supply chain, figuring out if there's layer 2 solutions that we could like route around these hostile actors. There are a number of different potential things that we could do. But again, none of them are like easy reaches or like easy asks of the Bitcoin network, either from a technical or frankly, more importantly, a social layer today. And so like the quantum debate, I think that, we really need to have a robust dialogue inside the community about like what would we do? Like what are our actual response mechanisms in the event that this happens, which again, in my opinion, would seem the logical endpoint of where things are headed on a long enough time horizon. And then how do we go about making those improvements? So, again, to me, I think the logic here is pretty inescapable. The energy is already exists. The jewels are there. The government has access to them. They're effectively free. The incentives are real. As I said, we're talking about billions of dollars a year in present value that we're both throwing away and allowing, or the U.S. government is allowing, or governments around the world are allowing Bitcoin to just go out the door. And people are starting to figure this out at the nation state level. So the real question, in my opinion, is whether the network will be ready for what comes next when this reality is broadly understood and we're actually confronted with the existential challenge of nation state hash wars. And so, in my opinion, I think we've already crossed the Rubicon. It may only be the first inning, but this is a game that I think we're currently engaged in, and in one that is going to become ever more important as each subsequent year goes by. And so, I would really want to ask everybody in this room to seriously consider this potential outcome and what we can do to prevent or maintain, let's say, the network as we, kind of love it and enjoy it and understand it today. So with that, I'll take any questions you guys have got.
Interesting talk. What are we afraid a nation state would do if they had 40, 50% of the hash rate? I mean, they're going to censor somebody, but there's still the other 60%. Like, why does it matter? I mean, we need consensus cleanup so they can't just break the network. Everyone do consensus cleanup work. But other than that, what are we afraid of? Who cares?
When you say we, you mean?
Like, who cares if a nation state has 51% of the hash? I don't care.
You don't care if they can reorder blocks or censor transactions or any of those things? What do you mean? Who's got the rest of them? Right, but if you can never regain control so that you are the dominant longest chain, how is that? Thank you, Shinobi. I'm going to take that as moving to the next question, but I'm happy to talk afterward. We should debate.
So there's a hardware element that's getting ignored too, right? Like,
yeah.
It just completely dismisses how much physical things would have to exist to harness that amount of electricity. Not to mention, it wouldn't be in a vacuum, and all the other nation states are the ones that matter would also increase, and you get that arms race, and so there's no gaining of control of the network.
Yeah, but if China controls the entire supply chain for
Right.
mining hardware.
Of course, but even if they did control 100% of it, what is the cost to harness that amount of electricity with chips that don't exist? I mean, it's a massive amount of material and time to create all of that, correct?
Well, yes and no. I mean, as we saw in the presentation, right, like they've got things like the Three Gorges Dam and massive industrial infrastructure project. I mean, they literally stamped down cities that are larger than anything in the United States in the course of days to weeks in China. I wouldn't underestimate the ability for China in particular to move into this market, which at the moment I would say is the primary risk I see. Like, I don't really see anybody as a material risk in this regard right now, today, other than China. But you have to kind of like complete the checklist of items, right? And the largest item that most people were unable to do or check off on the list was getting access to the energy, right? Energy is the primary input cost in Bitcoin mining, and so if you can't get cheap or zero cost energy, like, it doesn't really matter, right? But once you have that, which China has in spades, then you move to the next layer, which is, do you have the mining hardware? And again, like in China's case, yes, they have literally all of the mining hardware. If they decided to cut the whole rest of the world off, they would be able to monopolize the entire ASIC supply chain for years, and nobody would be able to catch up for a long time. So yeah, maybe hypothetically there's a universe where like China makes a move like that, the network decides to brick all of their ASICs, we make a proof of work change, move to some new hardware scheme, everybody has to start over from scratch. But even if you were gonna do that, when you restart, presumably, again, you're still gonna have to be bounded in a proof of work context to energy as the primary input. Nothing changes from the competitive positioning that you were in before. Now you're just in an even harder ground race when it comes to like hardware requirements, and do you have access and ability to produce that hardware at the speed that, again, like today, the Chinese can? I would argue nobody in the world can compete with the Chinese today on hardware manufacturing. So again, like, I don't see this as a game where we have like 20 or 30 competitors right now. It's primarily the Chinese, but I think that that's an existential enough risk that even now we should be very concerned about it.
So a couple of thoughts would be, one, when you're doing the breakdowns of the sources of energy in the world, it'd be an interesting piece to look into of, to the earlier point on CapEx, what is the potential, like, I know you wouldn't be able to have those exact numbers, but how much rough circuits of ASICs exist even, and where are those geographically located? I think a very happy stalemate would be a third of it living in China, a third of it living in Russia, and a third of it living in the United States, because they're very unlikely to all agree with each other. Right. Yeah. And I would more mirror the United States position of strategic ambiguity than a one China policy saying that China has the manufacturing today, because it's in Taiwan, most of it with TSMC.
Yeah.
So like, I think that's an important asterisk where that could easily flip at a switch notice. Like, there could be a global conflict and that could just become Chinese control. But as of this moment, with Taiwan not being 100% under Chinese control for the distribution manufacturing things through TSMC, is just another element to keep in there. But that'd be interesting to like think about. You have a massive, like with Moore's law cascading off, where all the S9s sure, they contribute some amount of hash rate, but it's a drop in the bucket compared to the X21s or whatever that's out now. Understanding what that current supply of chips are out there, and then like how long would it take to do that?
Replicate.
Not to mention, with the push of all this AI compute now, it's harder to get space on the fab floor to even make new ASICs, right? There's actually a possible universe where the hash rate's going to kind of plateau because, you know, Google, Meta, and NVIDIA, they're just going to own the entire chain of building these things, and no one's going to care about ASIC, and also for energy consumption too, I guess.
Yeah.
But those would just be interesting things to think about in general.
No, I love that you brought those up. That's actually two. I don't know how. I know we're like over time. I don't know if they're going to cut me, but yeah, like the two things that you mentioned there are actually two of the best like good news stories about the risk. If this were 3 years ago, pre-AI, I would have been like 10 times as concerned. But now there's actually something else to soak up all of that energy that actually requires you to make a trade-off decision. So the very existence of AI and its competition with Bitcoin hash rate is actually good for us as Bitcoiners because it kind of prolongs and delays this argument that we were just having. And then man, there was a second thing you touched on there that I forgot, but I would going to go to the next question. And yeah, no, it was great. No, but it was awesome. It really is.
So we're technically on a 20-minute break, but I'll let the Q&A keep on going. We have fresh coffee and all of the Costco snacks you'd ever want in the other room, and more Q&A.
So you mentioned like most of your numbers are based off of like curtailment, where it's just like wasted energy.
Yeah.
But like from my understanding, it's like that's not just like a constant stream you can just like tap into. It's like most of the time the wind farm is underproducing, and then massively winter day, and we just burn it all. So you can't really use that to mine because it's like you'd have to have like that many ASICs there, and you could use it for that like one day. But most of the time, those ASICs wouldn't have any power to do because you're just selling it to the city and stuff.
That's true in the case of like wind in particular, or also to some degree solar, where you might not have like good weather or something like that. But that's definitely not true of things like hydro, geothermal, nuclear, which are all like why I kind of centered the numbers around those.
I see.
But your point is still well taken, which is that there are sort of challenges to connecting these things in. There's another version of this that's also about sort of strategic defense, right? So like the examples of like the Edwards Air Force Base, sort of example, like there are thoughts around, for instance, let's say that China were to achieve a dominant hash position on hydro resources that they had that were much larger than anybody else could compete with. Well, what's to stop an F-18 from flying over and dropping a bomb on the dam? Like now it's a very hard thing to just reconstruct and plug back in. But without getting too far down the rabbit hole on this thing, like you can imagine that sufficiently motivated governments of a certain caliber, the United States, China, kind of like a handful of the ones at the top, they are capable of doing this, and they're capable of utilizing 24/7, 365 baseload demands.
Oh yeah.
Yeah.
I was just going to say, in light of what just recently happened, a couple of days ago with the admiral that talked about the military, do you see that in this framework, that's what they're starting to realize it is a strategic concern?
Yes. Yeah. I mean, I actually think that probably was among the most, proof positive and like happenstantial things that happened 2 days ago, right before I was coming to give this talk. It's not a surprise that the Navy, who operates the largest deployed nuclear fleet in the entire world, the U.S. Navy, operates the largest deployed nuclear fleet in the entire world of anybody, right? Even like the French government, for instance, which is one of the largest nuclear generators in the world, like they're not as big as the U.S. Navy. It's not a surprise that they're paying attention to Bitcoin. And it's not a surprise that they are, again, aware of things like hydropower and things of this nature. So I would say that, again, this is something that the governments aren't talking about too publicly, but they are, in my opinion, if you read the tea leaves, you can see pretty clearly that they're doing a lot of work on it on the background, and they can kind of see what's coming. And so naturally, you would expect that like China and other kind of global adversaries are also paying attention.
So not all nation states benefit the same from debasement and stealing wealth from their citizens. Do you think that there's a possible future where the big three, maybe top 5 nations, have an incentive to attack Bitcoin, meanwhile the El Salvadors and the Bhutans and other small nation states actually defend it?
Yeah, so actually you gave me the connect back to Rob's point that I'm going to come back to. So the other thing that is actually encouraging to me about this situation, having gamed it out with some friends who are core devs and kind of thinking about things, is that we kind of benefit from the 18th century balance of power dynamic, right? Where nobody wants one individual to get so large, and so you would naturally see these clusterings or groupings of people who have liquid sort of friendships with one another, where you could see okay, if China were the one that was going to try to push to a 51% attack on the network and had the means to do that as a plurality winner, they probably can't compete with the entire rest of the world saying, we're not going to allow you to take over the chain, and we're going to do what we need to exclude you from the network, right? And so in the same way that we saw European monarchies in the 18th century, nobody could get too powerful, because if they got too tall, everybody else would come in and make war on them. I actually kind of believe that might be the actual answer, even if governments end up pushing all the commercial people out of the sector and it becomes an exclusively government thing to mine Bitcoin. You could still see a universe where the balance of interests is such that everybody collectively can exert pressure on one or two small players, regardless of size, in order to get them to abandon a hostile attack on the network. So I would hope that game theory, which we saw play out in prior eras in kind of a more analog military context, would apply here. But I think the short story is we just don't know, right? And I think for a project as important as Bitcoin, we should have more solid answers than we don't know what happens when China or X nation state has the ability to hostile capture the network, right? We need to have better answers than we currently have. So, did that sufficiently answer your question?
Yes.
Okay, yeah. Thanks, everybody.
All right. The final discussion for the day is Bitcoin without controversy. I think that's what it is. Yeah. No, it's not. We'll see about that. Okay, so I did not prepare any of the co-panelists here today with what the questions are. But
no one even told me I would be on a panel, so.
Well, you were told just now, so here you are. But you're all vets. You'll be able to handle it just fine. Let's start with introductions. I think most people already know who these fine gentlemen are, but I think it'll be helpful for the topic to introduce each of yourselves with a little bit of the controversies that have surrounded you. And so the opening question I'm going to start with is, what is the most controversial thing you've been involved in, proposed, or helped develop with? And what is the least controversial thing that you've been involved in that you think should have been more controversial? Ideally, you can answer both of those, or you can pick one. But yeah, let's start with you, Peter.
Well, I have to go clarify the most controversial Bitcoin thing I've been involved in. And bizarrely, that seems to have been Libre Relay. I mean, if it creates a hat, it has to be controversial.
That's right.
But, maybe something that I managed to go push through that should have been controversial, let me think. Maybe something actually seemingly boring, like setting end lock time on transactions, because it turns out of privacy issues that no one really flagged it. So yeah, you should have pushed back on that.
There you go. Jeremy?
Yeah, so let's see. In terms of most controversial, that would probably be proposing Bitcoin have covenants. And I, originally made that proposal in concrete form in 2019, and so here we are.
Who doesn't want to secure the bag, though?
I guess many do not want hyperbolic opcodes in Bitcoin, and so for whatever set of reasons that was really controversial, I think the thing I would say on that I'm most surprised about is that like 7 years later, that's still like a main topic of conversation, that like, oh, we could do this one. And I guess that shows that it really is truly very controversial, because it would have been decided yes or no like much faster if it weren't controversial in some way. And then I guess one thing that I was involved in that should have probably been more controversial was with like taproot activation. I sort of maybe unofficially took the role of like progress whip at some point, and hosted a set of meetings to make it go forward. Personally, at the time, I was kind of like anti-taproot for some reasons, but I wanted to see progress happen, and most people were like really excited, so I favored like the consensus. But I thought at the time, taproot probably should have been a little bit more controversial, but it was like I wanted to see things move forward. But now it seems like it has become more controversial that it wasn't controversial, which is interesting to see.
I guess in some ways the most controversial is the same as Jeremy's, which is that I just proposed that we do soft forks. And I kind of, when I say things like I just did in my talk just now of, you know, soft forks, chain splits, they're okay. Certain people treat that as though it's blasphemy. So changing Bitcoin is the most controversial thing I've been involved in or tried to do. In terms of things that should have been more controversial, well, I guess it's a different take on Jeremy's. The late changes to Taproot all sounded really good. In particular, going from 33 to 32 byte, the gigglers here, pub keys. I was supportive of that at the time, although I wasn't a public figure really in Bitcoin yet. And it turns out that late changes to anything Bitcoin related should be looked at with suspicion.
Awesome. So yeah, I think that this is a good segue to one of the first questions I had to present to the panel here. So when Nifty asked me to moderate this, and she told me the topic about Bitcoin without controversy, my first kind of question that came to my own mind was, is that something that we even want? Is having controversy maybe a good thing? Because of like some of those last two examples, like maybe a little bit more controversy could have helped, actually all three of them, like could have helped bring issues to light. And so just thinking maybe we could go through the line again and just talk, maybe just if each one of you could just define what controversy means to you. Like when we say Bitcoin without controversy, like what does it mean to be without controversy? And then is that something that's desirable?
Well, I think there's two very different classes of controversy. One is things where the general public gets involved, and one where it doesn't. And, you know, if you have, like, depending on how you've achieved no controversy, this can be very bad or actually kind of good. In one way it can be good is because you just do really solid engineering and everyone figures out the right way to go do something. But that tends to be hard on projects that are actually difficult. But when you kind of involve the general public and it becomes a political thing, depending on what you're talking about, you know, sometimes that's just a giant waste of time, as in people getting really angry about Libra Relay when they're just going to lose, and that's that. Other times, it's a really fundamental question about, well, what Bitcoin is. And I'd say the block size debate was an example of public controversy that ultimately was good because it really said, well, what is Bitcoin for? And that is a genuine, you know, non-technical discussion that you can go have because your goals are not necessarily technical. Case in point being, you got systems like Tron, which are just fundamentally centralized, and they work fine for the people who use it, and you know, they seem happy with that. And it's hard to go say that's wrong from a technical point of view. They're just making different trade-offs than us.
Yeah, I think that controversy is good. Controversy many times is you know, vigorous debate, which I think produces some of the best outcomes. And I think that where we've maybe, you know, in some senses failed is not making the most meaningful places controversial, and instead having controversy over like squabbling over like less important details, rather than over like the most meaty or difficult to solve problems. We've maybe avoided those and favored easier to pick battles.
I think that, similar to what the other guy said here, the controversy is a critical part of being human. And we wouldn't be building a system that involves humans if there wasn't controversy. But I think the challenge we have in Bitcoin is in selecting who to listen to about what things. And so we have let things become controversial almost for the wrong reasons at times. So there's a challenge there, and I mean I'm guilty of it too. So I'm not throwing stones or anything, but we should be mindful when we engage with people that we are engaging with people where it makes sense to, and not letting a controversy grow by the fact that we're engaging in it when it's not helpful.
Yeah, something that I think was repeated in most of those answers is there's like a certain subjectivity, I think, to the what is worthwhile controversy versus what's not, and like so, one of the things that I think is challenging in an open network and decentralized development experience is like, okay, how do we decide what should be engaged with? How can we push things forward? If maybe there's not enough like public controversy, like how do we maybe push that and then disincentivize the less constructive controversy? Or is that even possible? I think people get kind of frustrated with, and again myself included too, in the quality of debate sometimes. But is there a way to get one without the other? How do we tamp that down, or do we just have to grow thicker skin? This is an open question. Yeah.
Clearly government censorship. We need to go form a state committee to decide what topics are allowed to be talked about on Twitter.
Well, if I could actually, that is something that people got frustrated with in the filter debates, right? Is that this debate was shut down on the GitHub PR, right? And there was some censorship. People were claiming censorship there. Is that desirable? Do we need more opportunities for that?
I think it's very desirable in that circumstance, because otherwise a bunch of idiots are just going to clog up your GitHub. And if those idiots want to go somewhere else and go debate things, fine. But of course, this gets down to how there's a mix of public and private going on there. And things like GitHub for particular projects are actually private. And unfortunately, people do have to accept that ultimately, if you really, really believe that Bitcoin Core is doing something wrong, you're going to have to go fork it. And you're going to have to accept that depending on the sort of change you want to make, that's a very easy thing to achieve your goals and a very hard thing. Easy in the case of Libra Relay. I didn't need other people to go run my stuff other than a small handful to make the change I wanted. And on the not side, they were just fundamentally picking a exponentially harder battle because their idea just sucks. And, they can go and have their separate spaces all they want, but it's just it's constrained by what's possible. Now, you could probably come up with examples of this where the nuance ends up being a little differently, where maybe you're pushing for something that's kind of good, and it's unfortunate that people can easily run code and screw it all up. But generally speaking, in Bitcoin, most from an engineering level, we basically just accept, yeah, that's possible, and try to write better code. And fortunately, we can be successful, because if we weren't, this whole Bitcoin thing would just fail.
If I could fork off of that for either of you two. So it's actually interesting, there's the difference between you're making changes at the mempool layer, which is, as Peter is pointing out, is you don't actually need that many people to be running your fork for it to have an impact if it's of the right technical goal. But the things that need soft forks, it's much harder. If you fork it, the barriers to entry for success and of persuasion are much higher. Is that something, I don't know, maybe both of you guys could talk about your experience. I know, Jeremy, you tried to do an activation client.
Yeah, so I think the one thing that, there's no clearly documented process for any of this. So whatever you do, it's the right thing or it's the wrong thing. And maybe that's vacuous, but there's no documented process. So definitionally, nothing is right and nothing is wrong. I think overall people should probably increase their disagreeableness, but then also increase their willingness to follow the leader. And I think that that's contradictory a little bit, but increasing your disagreeableness can look like saying, okay, somebody tells you their idea, tell them all the reasons that it's bad and come up with something that you think is better. And then the follow the leader side could be like after a year of like discussion or whatever, just going, okay, well, after this is clearly the line is this going to fuck up Bitcoin for good? Yes or no? No. Okay, let's go with the leader on what seems to be like the best. And I think that a little bit more of that is better than what we have right now, which is a lot of just sort of like waffling on issue, which delay is not necessarily in any of our interests, especially maybe covenants are fine to delay for a long time, but there are other issues that you might want to more meaningfully address. And I think that is probably a part of it. I think also, at least within the Bitcoin community at large, people get very maybe cliquey around how they use their like points of control on discourse. And I think that maybe part of that is just like calling that out if you see sort of development or like scientific censorship, and then leading by example of just like participating more and saying what you think in more like well documented ways. But
could you define the getting cliquey and then the scientific censorship and maybe some examples?
I think that I'll just speak from my personal experience, and I guess I'll dox myself on this. But at the time of Taproot sort of coming out of the muck, and this is kind of a funny point with what you mentioned about like late changes are bad, is that I think if you look at the timelines, like Taproot had those late changes in like, was it 2020 or 2021? Yeah, and then merged and then activated later. So CTV hasn't changed since it was released more or less like December 2019, January 2020, which means that like at the point where Taproot was merged or whatever, it was actually younger because it had changes than CTV was. So that was the thing, and I was advocating for CTV because I just thought, oh, we have version bits, we can have independent upgrades, we can work on things independently, and an advocate for a technology should just be like pushing it and describing it and saying what's good or what like what it can do. And so I was doing that, and then I started getting feedback, basically kind of like behind closed doors of like, you are going to ruin Taproot for all of us, and like this is really like bad that you would do this. Please do not do this, and if you do this, we'll like ruin your career. Basically, was like the feedback that I was getting, and I was like, okay, well, like I am not really like funded, so I don't want that to happen. And I'm not like opposed to Taproot, but I'll take it on fiat that this will be bad for Taproot happening. And then as I was thinking more about Taproot, I actually started getting a little bit more confused about like the design trade-offs, and I no longer thought that they were reasonable. And I had a conversation with some other people, and I expressed what my concerns were, and they were like, yeah, like I haven't seen any of these points really addressed. Those are entirely valid points. And here are some other points. And I said, okay, well, I'll draft up a letter detailing these points and some other points. And then I was like, okay, well, am I going to like post this under my name? And then I was like, well, everyone's told me they're going to ruin my career if I hold up Taproot, and I'm working on CTV, and so people are going to view this as, oh, I'm trying to sabotage Taproot to get CTV, which is not my goal. My goal is for Bitcoin to progress. But people have made it not really about the quality of like scientific discourse. They've made it about the reputations and things like that. So then I published the letter anonymously, which was like a huge pain in the ass to do with like the Bitcoin forums at the time. People didn't really like deeply engage with the criticism, which was more or less now where we've arrived with what's at BIP 360, where it's like raw. Like my proposal was just like, oh, we should just do raw tap leaf, tap tree instead of with the tap tweak. That doesn't make sense to me. And like now we've come back there. So if we'd actually had that open scientific debate, maybe people weren't paying attention because I wasn't doing it under my name, and it carried less weight when it's just like an anonymous, throwing out. And so that is kind of a regret of mine of that. But if you look back at like, well, what are the community cliqueness and like pressures of like, hey, we're gonna like advocate against you ever getting funding, or we're gonna, go against anything you propose ever again if you sabotage Taproot. It's like, okay, well, I better get in line and help Taproot and like shut up about my like reservations about the protocol if I think that they're still survivable. And so then I did that, and then once Taproot was sort of like merged, which I thought was like my goal of getting it merged with like release parameters, I was like, okay, now we can look at CTV, and everyone's like, oh no, we can't because we just had Taproot and it's way far too soon and we can't look at it ever again. It's like, okay, well, clearly I don't understand what this process is, but it's not a real process. It's just like groups of people who feel like they can do things and people who like are outside of that group. I don't know if that makes sense.
Well, I want to say like a really key thing about the process is you have to go and build consensus around an idea that it's important enough. And I'm probably the author of the least controversial new feature added to Bitcoin, which is check lock time verify, which was a very easy thing to go push through because it was just so obvious that clearly you're going to need this. Like, I wasn't even really the one who kind of identified it. I was just one of the people who said, well, yeah, obviously you're going to need this. I might as well go and actually go do it, write the 5 lines of code it is or whatever it is, and just do it. And that was a very easy process because it's easy to build the consensus, say, yeah, you need this. Obviously, we're going to need it for channels in some way. And Lightning channels to this day do use it in certain cases, and there's no real replacement for it. And immediately after, we got the relative lock time check sequence verify. And again, the process for that, other than certain technical details, but how exactly it worked in certain cases, was a very easy thing because it's like, yeah, well, we definitely needed absolute, we definitely need relative. All right, let's just go push it through and we're called it done. And I think the problem there is that example is hard to replicate because then you get things like check template verify, which is like, well, do we really need it? I mean, what percentage of use cases is going to actually do this? Clearly with Lightning, we expect basically everyone to go use Lightning in some way. And at the time we didn't call it Lightning, it was some kind of payment channel. Yeah, template verify, it's just not so clear. And quickly it goes down the weeds. Whereas let's say Taproot, yeah, maybe certain technical choices you can push one way or the other. But the idea that you have some kind of Merkleized script thing, it's just so obvious. Clearly you're going to need this. Maybe there's slight differences in how, but like it's such an easy thing to get through. And yeah, maybe we should have done 33 bytes instead of 32, but clearly you're going to need something like this to just get out the door.
So just a fun fact is I think roughly 1/3 of value in Taproot addresses is like publicly documented as using CTV emulation. So like I just don't think that we can centrally plan our way to, well, clearly people are going to need this or not because like
yeah, but I mean, had
things.
you designed like Bitcoin from scratch, you would have gone to Merkleized scripts. That's just how you would have done it. I mean, it's such a clear thing. Now,
but Taproot's also the tweak. So if it's also the tweak, you wouldn't have designed the tweak.
Hang on a second. I'm saying, clearly you would do that. Now, it's a little like, since you have Taproot, it's not so clear that people are immediately going to start using it. And there's a massive upgrade time it takes with wallets because wallets is dangerous code. No one wants to be the guy who screws up $500 million and loses it to some bug. Like I've been in the position of auditing that code, and it really fucking sucks. And if I remember correctly, last time I did that, Taproot was an option. And my professional advice was, yeah, don't bother with it. Like, let's just keep this thing that currently works. So how much value is in one or the other, I don't think is a really good argument here. But you can make the really good argument. Certainly, if we went back in time to 2009, you'd say, yeah, obviously Merkleize this.
But I think you'd also, if you were designing Bitcoin from scratch, you'd obviously give people a way to check transaction hashes with or without a signature. The fact that it doesn't have that is an accident of Satoshi using off-the-shelf stuff and then adding op-do Bitcoin in the form of checksig that did multiple operations in one, and that's merely an artifact of kind of accidents of Satoshi as opposed to an intentional design.
I actually disagree with that because the sort of constructs you do with that really get into the weeds of exactly what the hell you're really doing. I mean, it's just so much simpler to conceive of, yeah, we're going to have scripts. Well, why would you have to reveal all the script? Why not put it under Merkle tree versus, well, there's all these kind of next level things you can go do with it, which are hard to go talk about. You know, even channels is just barely within the realm of, yeah, it's kind of obvious. I mean, I'd actually make the argument, I mean, Merkelizing scripts is more obvious in 2009, in a sense, than the idea of channels.
Well, okay. Well, let's have some more controversy up here. If you look at things that Satoshi talked about and were talked about early in Bitcoin, people did talk about kind of chains of transactions, essentially predefined chains of transactions. And that's exactly what some kind of hash across the next transaction allows you to do, is chaining transactions. At the time, of course, because of what Bitcoin did, they were talking about chaining using pre-signatures. And so it's a weird thing, I guess, where the conversation happened in the context of signatures existing and being the only way to access a hash of a transaction. But that same conversation would have happened with hashes of transactions if it had been possible at the time without the signatures.
Yeah. Well, I think also another reason that it's not so clear is that not that we'll take Ethereum's design as any sort of gospel, but they obviously designed after Bitcoin and designed with an idea of like, okay, we're going to improve a lot, and like Merkelized script is not a part of Solidity. It's something you could like theoretically do some Merkelization within your program itself, but like the actual scripts aren't Merkelized.
I wouldn't make that argument because I'd say Ethereum's design was not about making a system that had good smart contracts. It was about making a system that was very easy for dumb programmers to think they could do something interesting by presenting them an interface that kind of looks like normal programming, which we know and we knew at the time when Ethereum was made, that's clearly not how you do it. I mean, that's just such a bad model to go work in. State machines are the right model. And Ethereum threw that advice out because they weren't trying to go create a good system. They're trying to go create a system that could lead to a big pump and dump.
But if you're saying state machines are the right model, then that's precisely not talking about Merkelization and precisely talking about covenants, which are an attempt at doing state machines inside of Bitcoin.
Right, because in a state machine, you're going to want to have state transitions that are authorized transitions and state transitions that are no authorization transitions, right? That's one of the fundamental aspects of a state machine in this system.
We're going to pull away from implementation details here, because those are fun conversations for at the bar. Right? We all love having those conversations at the bar. To bring it back to the topic of Bitcoin without controversy, I think one of the interesting things that you were describing there, Peter, is I think that there's this idea of like, how do you measure controversy? And I think one of the things that you highlight, like SegWit and Taproot certainly weren't. Taproot was less controversial than SegWit, but turned out to have more controversial things after the fact in terms of like its activation. There was like very little controversy about the activation itself. Check lock time and check sequence verify, very little controversy, but also the community of developers was much, much smaller. I remember having conversations with colleagues at the time of the block size wars, and this one colleague happened to be very into Ethereum, and I remember his comment stuck out to me so much because he's like, you Bitcoiners, like you have all these fights about stupid things, but we in Ethereum, we've actually solved this already. And I was like, no, your community is just a bunch of friends that are working on a project together at this point in time. You will have controversy. And so I think there's this element of like, and I've seen this around a lot of the software, it's like, well, this project or this proposal has too much controversy, therefore, and we need more consensus before we merge it in. But at the end of the day, it's like, what is the level, like how are we going to measure what is the right amount of controversy? Because at a certain point, the community gets big enough. I mean, full RBF and the data carrier changes were not without controversy. There were still good changes, I think most people would agree, but they were super controversial. Should we not have done them? Were they not that obvious?
So I think a very interesting thing about those examples is it speaks to when you want to measure controversy, there's different ways of measuring it. And I would say, the data carrier controversy is a good example where the controversy among people who understand the tech was pretty low. Controversy among people who didn't was very high. And in an example like that type of controversy, I would go argue, because of how I'm happy to work and sort of what social environment I'm happy in, that didn't matter. I mean, I don't care how much Luke hates me. It just doesn't matter. It's just completely irrelevant to me. And, in that respect, from my point of view, those are very uncontroversial things because I can just go put in Libre Relay and like it just magically happens and that's that. And they can argue all they want, but it just doesn't matter. So yeah, to me, that was extremely low controversy. Now, if I was to do a consensus change, I mean, let's just say hypothetical, like some kind of either tail emission or demurrage, I would expect that to be extremely controversial in a way that's unavoidable because I actually have to go and convince people who are not me to go do things. And that controversy is a very fundamental thing. Now, if you go back to, say, Ethereum, well, so much of why there's just not much controversy in something like Ethereum is it's just inherently very centralized. Very few people actually run Ethereum nodes that matter. When you get to chains like Solana, it gets even worse. I mean, crazy examples. I actually had, I think it was in Kiev or something, someone at a conference told me that they had a budget of like $1 million, something like that, to run a genuine Solana node with full archival history. And they spent the money trying to achieve this for like a year, and then eventually just gave up and realized it is actually impossible to get the full history because people who have it won't give it to you. Now that's a type of system which has very low inherent controversy for consensus changes because so few people are actually involved. Bitcoin is not that.
So interesting anecdote, because you mentioned the people who were against the recent relay changes are the ones that didn't understand it. One of the things I found, frankly, very, very surprising when I was about 2 years ago going around advocating for CTV as part of L-Enhance was people who I considered experts in script and Lightning literally not understanding how CTV worked and how CTV plus check from stack was roughly equivalent to say cache any prev out on your signatures. And so in that case as well, actually, the people that were pushing back were people that literally didn't understand what the things did. But that didn't take away the controversy.
Well, unfortunately, I think that's an example of you probably running into that in part because the things it enables just aren't desired enough for people to bother putting in the effort to truly understand this thing.
Right, but that applies to like do the things that are enabled by expanding the data carrier size, do they have that level of importance?
Let me put it to a better example, as Jeremy explained, like when it was proposed that there were some design issues in Taproot, and that was pointed out to the people that did care about it, that did want it, and did want to build on top of it. They were not aware of the issues that it had been that were in that design.
Well, I'd say the issues potentially you have with Taproot are things that are minor issues around the periphery of what Taproot is. Now you can go make an argument, well maybe quantum stuff is going to change a bunch of things, but that's kind of a separate argument there. And that's, I don't think, is relevant to the discussion that was had as Taproot was coming. 32 bytes versus 33 bytes, that's an optimization thing, but it's not like really fundamental. Whereas
it does create the issue that you were talking about in the complexity of while it's implementing it.
Sure.
And there were a lot of bugs that were introduced, and people lost Bitcoin because they miscoded that change.
I
Again,
don't
it's
think
not the same as like a protocol level thing, but
it's a lesser degree of controversy. When you look at the fundamental design of it, of let's Merkleize script, that is something which is very easy to get around because it's very obvious. The exact details of how you Merkleize script, there's some controversy there, but it's a very different thing. I mean, I'll give a really extreme counterexample. It's a very different thing than something like drive chains, where the very idea of allowing miners to do things this way is fundamentally incredibly controversial.
So I think also for Taproot, one thing is that I agree that you can get lost in some of the minutia of it. And obviously, today if we had 33 bytes, a lot of things would be easier. But some of the controversy as well is just like really buried because there's a little bit of maybe monoculture. And I think one of the examples of this is that Taproot probably should have used BLS signatures. And the main reason is there's a pairing assumption, which is a new cryptographic assumption, which is bad for reasons. And it's a new curve because SecP doesn't support one. But the sort of weirdness of it is that it's also it's a little bit of a blame game issue as well, where if devs introduce a feature and it's somehow insecure, they really don't want it to be particularly like their fault, and that's fine. Taproot, in a sense, is designed with a very high preference for if something breaks in your wallet stack, it's not the Bitcoin core dev's fault, it's your fault. And the level of that is basically that you end up with musig, which is incredibly complicated to get right. And you can say, oh, it's simple. Okay, we've gone through many iterations of musig that have had various bugs and vulnerabilities that have been relatively difficult to find. Maybe it's in a good place today, but it's not widely deployed. In BLS, all of the complexity of multisig aggregation is basically contained within the pairing assumption. And it's so easy to write the aggregation. A child could do it. Maybe one person in particular is child here, but it's really not that bad. And if there were a problem in it, it wouldn't be in the wallet author's code, but it would be in the pairing assumption, which the core devs maybe vetted. So there's maybe a little bit of conservatism in who gets the blame. At the end of the day, it doesn't matter if your coins get stolen because there's a bug in your multisig code.
I got to point out though that when you go back to when Taproot was created, the academic understanding of Schnorr was that, oh yeah, this will be quite easy to go do that. And I would not be surprised if, let's say history had gone differently, it could have easily come out that these BLS signatures actually turned out to be way more difficult than we thought. In much the same way as that when people finally used Schnorr in production, which was really Bitcoiners, realized actually this is hard.
We knew that musig was going to be hard because there was no security proof of doing that yet.
I would not agree with you there. I'd say Schnorr, we believed based on the academic research at the time that this would be fine. And then academia itself found actually we screwed this up, and our understanding of Schnorr signatures just was incomplete.
Yeah, I mean,
and this is harder to do in these constructs than we expected.
I mean, I think it was at the time that this was being discussed, Bram, who is still around, really did die on the hill of you guys are being incredibly stupid for not just doing BLS signatures, and he said that basically as often as he could say it.
One thing that is worth mentioning here is that in both cases, you're pushing some complexity onto wallets because the wallets either have to now have the ability to generate keys on two different curves and sign on two different curves, or they have to deal with the complexity of implementing musig. I don't think there's an obvious win here, one way or the other. I do think it's worth emphasizing that in the implementation difficulties of musig, the final published specified version, musig 2, having implemented it in several languages, about 1/3 of that complexity comes from simply the choice of 32-byte keys. And that's where a lot of the errors in early implementations of musig happened, is dealing with the parity bit flipping back and forth in the right cases. So there's always trade-offs of where you push complexity and where you push costs. It's not free. BLS wouldn't have been a free win. It's just trade-offs.
I mean, at least I can go say, I think I may have even said this publicly, the whole bit of trying to reduce the keys by 1 byte, to me that seemed like this is stupid. In the same way as that Beck32, putting all that complexity just to have a slightly better checksum seems stupid to me. But, I'm a lazy engineer who doesn't like to go do work. I'd much rather just do something simple that works.
So I'm going to ask one more question before we open it up to the audience. I think one of the things that has kind of become clear in this conversation so far is we all agree that controversy is a good thing, and in the right doses it allows things you need sunlight to kind of is the best disinfectant type of idea, but the challenge is how do you measure it? What is the right amount of controversy? What is how do you evaluate in as objective a way as possible what is quality controversy versus what is just noise? And one of the serious challenges that we've seen come about, I think especially in recent years, with that difficulty is that controversy, while maybe good, can also impact the cost of development, especially in open source. And so we've seen people get kind of burnt out from having to deal with this, and so there's this inherent tension, I think, between having an open source kind of development ecosystem, but one that doesn't have kind of a centralized leader that can kind of, like you see, like Linux is a great, is a model that a lot of Bitcoiners think about, and yet it still has more of like the centralized leadership that helps to keep these things under control. And so I guess the kind of like last thing I want to kind of put to the panel here is like, how do you guys see this tension between free and open source software and the costs of controversy on that community and like healthy development? And how can we maybe protect because I think, Jeremy, it was a couple years ago, you were like, you had to take a break from Bitcoin as a result of some of the costs of this. So yeah, if you guys can talk about that tension and maybe how you see us as a community maybe able to deal with that, or maybe it's just acceptable.
I don't like this example of Linux because Bitcoin is a consensus system. It just has fundamentally different characteristics than basically everything else.
To be
on
clear,
the universe.
I'm not using that as a comparison. I think we look to that as an example of this like open source protocol that a lot of people use. My point is basically like is exactly that. You can't use that as an example because it is fundamentally different.
Well, and an interesting thing there is the way people actually use Linux in practice gets filtered through all these distributions that do so much more work on top of the kernel that Linus ultimately blesses. And that's just so different than the Bitcoin world. Now, the closest I think we have is probably Lightning, where you certainly can have different Lightning implementations that disagree about stuff, and it's fine. To various degrees of fine, depending on what exactly you're talking about. But a great example is like you can have different, good examples like taproot channels. LND supports taproot channels between different LND instances. And you can route over taproot channels publicly because, if I'm at point A and, you're at point Z, everything in between, it doesn't really matter to you. It's the HTLCs is all that matters.
But that only works if the base layer is operating
correctly,
right? So
it works. Hang on. So with Lightning, it's weird because you can route HTLCs over things that aren't even real. And that's a weird thing to wrap your head around. Now, you can make the arguments that you ultimately do need Bitcoin, and thus you need that kind of consensus. But you see how it's a weirdly separate thing?
Yeah, I mean, so the question is like, how do you deal with, like, Lightning is not a good example, Linux is not a good example.
I think, we are our own community, so, things will just be bespoke for us. The main thing maybe I would impart on this is that I think by and large over the next year or two we probably need to mostly abandon all of the online communications. I think that they're going into the.
That's impossible.
Well, if you'll give me a sec, it may be impossible, but at least in terms of quality of discourse, it's rapidly raced to the bottom of the worst slop. And so I think in a previous generation we took as a strong cultural norm to make everything as strongly remote participation accessible as possible. And I think that was because you wanted to open the funnel as widely as possible for participation and be decentralized. And I think with the slop tools, it probably needs to
the what tools?
Slop tools, like GPT and Claude and all friends. That probably it's a lot more important that somebody in person, live, can explain a concept and discuss and debate. And I think maybe this is something for the event organizers in the audience, but having either professional scribes or things at events to sort of note down what was discussed, what types of things were done. I think we'll just see a collapse of context and nuance in a way that almost nothing will be able to be nothing will be able to proactively be worked on when you could write something that's a good idea and then have 10,000 pages of support and 10,000 pages of against generated almost
the cost
instantly.
of disruption is rapidly falling, basically, right? You can disrupt, you can create alternative arguments and even implementations at way cheaper. So
yeah, and the quality bar just you need to raise the costs basically on proof of work for contribution.
An interesting analogy that I often think about is you have the French and the American Revolution that happened basically at the same time, and the American Revolution, especially when they were writing the Constitution, happened behind closed doors. No one was even allowed to take notes. There was a couple dedicated note takers, and then and eventually successful. There's a lot of debate still, a lot of controversy, the Federalist Papers, and then the French Revolution, in contrast, had everything out in the open, and they ended up chopping off tens of thousands of people's heads, and like it feels like
Sounds
a good
like Bitcoin.
yeah.
I really can't agree with this because the online tools are already plenty good at making AI slot bot matter. I mean that's just not the relevant issue here. I'd say the bigger fundamental issue we're all running into is just the easy ideas are already taken. Now we're talking about much more niche things that just aren't that relevant. If you want to go push Bitcoin forward, the way you push Bitcoin forward is working on stuff like Lightning, which doesn't need much in the way of consensus changes or even any. I mean, look at the ARC guys who figured out all kinds of stuff they can do without any changes to Bitcoin. And that is a much more productive process going forward.
Maybe debatable. Brandon, do you want to talk about the developer burnout question or?
Sure. I mean, just briefly, another thing that's important here is kind of different than Jeremy's point. Just the changing from fully public discussions to semi-public. I've noticed in the last 5-ish years, my online time shifting from on X primarily to being in group chats and places like that, where it's not truly open entry, it's almost open entry. Because, yeah, the level of slopification on X and other public forums is just so high.
But I mean, that's not even how we did forks in the past. I remember the process being in the past, lots of private stuff. Like a lot of us, wouldn't necessarily know about this because they weren't there, but there's all kinds of private discussion on all this. And it always gets down to the nuance of what exactly are you trying to go change and how that process will be. Yeah, and if hypothetically there was something as simple as obvious as check lock time verify again, I suspect the same kind of approach would work just fine. But you run into the problem of what are the types of changes people want to make, and fundamentally the landscape is just different there.
I think it's just the gain function is basically gone from it being default things don't get amplified to default things get amplified, and I think that that means that when quality thinking is happening, it will be more in whispers than in shouts. And I think that that's whatever mitigates that. I don't think that
this
it's
just
likely.
Feels to me like someone butthurt that other people don't think their ideas are that quality.
I'm not even talking about anything specific. I'm just saying if you wanted to go say anything, you're getting a massive feedback loop of AI slop right now, and that may or may not matter.
I just don't think that's that different from the sort of bullshit discussion we had around block size wars. I mean, we had the same kind of thing. It's just instead of AI, it was paid actors and just stupid people. And that's not that different from AI. And again, the solution there is obvious.
AI is cheaper, right? So you do the same thing, so you can do it at greater volume. But it's not
significantly different.
No, nobody's arguing it is.
Well, because the tools that we have to combat that type of thing have always been really strong, which is go have identities. And these identities, you go build them up by making good arguments, and that's just as true now as it was in the AI world. But what has changed is that the level of quality of the ideas people are pushing out and the level of impact has just fundamentally gone down because we've done all the easy stuff. Now we're doing harder things.
Sounds like we're measuring the easy stuff based off of lack of controversy, but when the community was a lot smaller, then therefore...
It's not about size. It's that we did easier things initially, and then Bitcoin got close to perfection, and now getting the next level of things is just fundamentally harder because there's a lot more nuance in what exactly is better or worse and a lot less impact in it.
So how do you measure easy and obvious?
You go and look at how easy and obvious it is technically. Like check lock time verify is a great example. It's such a simple change that clearly made a lot of important things better.
I've got a good litmus test for you is op I key. So op internal key. Really easy, really obvious. Big improvement for anyone.
It is just not as easy and obvious as something like check lock time verify. It's much harder to talk about.
Op I key is definitely easier than check lock time verify.
Yes.
Yeah, but it's not obvious the impact. That's the thing.
It directly impacts Lightning channels by saving them 8 virtual bytes in
And Tapper
forced poses.
was infinitely more complex than any of these as well.
But Taproot, the basic idea of you go Merkleize things was pretty damn obvious.
Right, but we didn't just do the Merkleize.
I think to engage with Buck's point is
no
like,
controversy, guys.
he's asking specifically how do you measure easy and obvious, and I'm giving you a specific compare numerically what makes op I key less, and you're just going, oh, it's just it's more complicated.
Look,
if you can actually quantify it,
we fundamentally
because lines of code, it's fewer lines of code.
Well,
like impact, it's like a very clear impact. All right,
it's not that clear.
There's not more than one way to implement it.
On that, let's ask if we want to let the audience, if you want to dig more into this particular question, you can, or if you want to ask something else.
I mean, should we start with the fifth panelist?
It should be merged and out today if it's so easy and obvious. But I think maybe something else has changed.
All right, 6 panelists here.
Can you show me on the doll where internal key touched you, Peter?
I mean, I don't really care about it one way or the other. I'm just saying the impacts of it are just not as obvious as something boring. Like, all right, it would be good if transactions could be locked at a certain time. Like, it's like...
You could lock transactions to a certain time before you had to check lock time verify. You just have to put it in the pre-signed transaction. Like, why?
Would you like to have more transactions per block? And would you like, for the same cost of bytes, and would you like to pay less for each one of them individually?
Look, there's all
This
kinds
sounds like
of
an attack on Bitcoin.
There's all kinds of little serialization changes you do that. They're just not that interesting.
Yeah, well, because it's easy and obvious. It's not that interesting.
But we saved a byte. It cost us hundreds of lines of code.
Okay,
with those stupid
no one is
Taproot
allowed
keys.
to say something is interesting or not interesting for the rest of this panel. That word is banned.
That's an interesting rule.
Or is it a retarded
It might be an
rule?
obvious rule.
All right, this is for each of you. So what's your most controversial opinion on Bitcoin Core specifically? And it like, don't like have any like restraint, just like say like, what is the most controversial thing you can think of?
Oh, I can think of something very easy, which is the current crop of maintainers are wimps. Like,
I call them children.
I said this publicly when Gloria left. It's like, if people get worried about this type of like so-called cyberbullying and all that, you're just not in a position to be responsible for a major implementation of like $1 trillion thing.
Are you offering yourself up as a maintainer?
Who wants to pay me for it?
Chain code, maybe? What?
I mean, C++ is boring, and I don't really care about it. But yeah, hypothetically, someone gave me enough money, maybe I'd go and do it. But and I think part of the problem here is because we did all these interesting stuff first, maintaining Bitcoin Core is just getting less and less interesting. And it's harder to go get people willing to go do that kind of boring task. And then you wind up with people who just don't have the right mindset to be responsible for something that important.
So there's, I'll say something which is maybe not well known, but does dovetail with that. Is that there's 2 levels of original sin within the Bitcoin Core project. You can maybe go back further, but these are like the most recent 2 levels of sin. And the earlier one is that Wumpus was made the maintainer. Now, this is to say nothing of that. Generally, over the course of their tenure, Wumpus did a good job as lead maintainer. But I think one thing that I remember being stated at the time is that, while incredibly gifted technically, Wumpus was in no way the leader of the project, and that it was actually to draw attention away from other people who are really, in a different way, leading the project. But we can have somebody who's less controversial. So maybe that's less controversy in Bitcoin. Who everyone could agree, okay, well, this person can do the work technically, but other people are pushing the project in the direction. So you separated the concept of who's leading the project versus who's the lead maintainer of the project. And then the second sin that went on top of that is that when Wumpus retired, which I guess Wumpus is back, but not in the same role or capacity. An experiment with no permission from the community, basically, not that the core needs, but it's not just permission. It's not even really like notice that this was an experiment that was happening. Is Bitcoin became the maybe first and only open source project in history to not have any sort of lead maintainer, and there's no lead maintainer today. They're just maintainers, and well, like. I'm not necessarily one to favor authorities. It's generally well known across lots of different consensus systems that you will almost surely make no progress without a leader of some sort or some process for having a leader. Even if you can fire the leader, not having a leader, no progress. And we're in a state for the last couple of years where there's no leader of core, and I think it shows for the quality of result. And whether or not you agree that this is a good idea, it is a separate thing from it's sort of like a unacknowledged experiment in project governance. And one rule that I try and say for people is, be really interesting in one specific way. Don't try and be interesting in two ways, because as soon as you go for the second way, you can get into a lot of trouble. And so if Bitcoin as a project is making the world's only decentralized, government-free money, that's really cool. That's really interesting. Okay, we don't also need to be the world's only leader-free open source project where there's no lead maintainer who can be fired setting the pace. So that double experiment for me is something that I think is completely nuts.
That really sounds like nonsense to me, because I am sure you could go find other examples of projects, especially like semi-abandonware stuff, that don't really
semi-abandonware stuff. You made the point.
That don't have a lead maintainer, and there's a lot of semi-abandoned open source software that people still use and works fine because you solve most of the problems. The other thing I'd go say is the idea Bitcoin Core's made no progress seems like nonsense. I mean, we've got Cluster Mempool, which clearly does all kinds of interesting stuff for niches, and that's.
I think Buck did a whole talk about this topic a couple hours ago. I do want to answer your question, so I'll put a different take on the Bitcoin Core, what I can say controversial about them. I'll say that Nick Carter and his quantum fudsters are absolutely correct that there is a dereliction of duty among the Bitcoin core maintainership. It's just not about quantum. There's a failure of leadership. It's just not about that.
That's maybe an example of it too. It's because there's no leadership, it makes it that you can almost view that as an attack on Bitcoin by distracting the development activity. If you don't think it's an actual threat, if there's no leader, then it's easy to get sucked down into other topics that are maybe not as important.
I'll go on a limb here and say I think if the quantum guys could actually go show that quantum was a real thing and not a whole bunch of hype, we would suddenly find out that, assuming that there were reasonable quantum secure solutions, that quickly get adopted.
Okay, so who in the audience would claim to be the foremost expert in this audience of Lightning? Somebody's got to do it. It's going to be probably one of you two. Okay, how does Cluster Mempool make your life better? And if you can just give us the.
Oh man. I'm not the right person to answer this because I have a beef to pick with cluster mempools, so that's not exactly
very
fair.
Interesting and obvious.
Sorry.
Totally worthwhile.
What was the?
Well, I think that the point is, Bitcoin Core is doing all these great things, like Cluster Mempool. Okay, it's great. It's supposed to help, protocols for some reason. How is it helping you?
Issue that they made with the one parent, one child thing. So they got to, there's some stuff that they had hacked into Bitcoin to help Lightning that they got to clean up. So there was some weird edges to the protocols that they got to clean up, but that they had to hack that into Bitcoin Core. The first one was in 2019, which they called the carve out. And the carve out wasn't enough, so they came up with this thing called one parent, one child truck transactions. And that has its own really ugly edge cases. And I think my understanding is that Cluster Mempool improves that.
Sets the stage to improve that.
I'm sorry. Yeah. Okay.
Yeah.
I'm sorry. I look like this.
And I want to be clear. I don't say Cluster Mempool is some radical thing that's going to change all of Bitcoin. I'm just saying it's a clear example of progress. And to go say Bitcoin Core does not make progress is nonsense.
It's a clear example of maintainership. I'm not positive it
Interesting
can be
and
defined
obvious
as progress.
example of progress.
I think we need beer for the rest of this.
So I think what I would contend is that if you did have a leader of a project, not that I'm saying we have someone who I'd say, this person should obviously lead core, is you might say okay, we're going to set a year goal to get the ship. And I think with Cluster Mempool, it is a nice example of a concerted effort among everyone to okay, we're going to really fix the problems that are facing the Lightning Network.
Done by the de facto leader that still exists in Bitcoin development.
Possibly, but it hasn't achieved that outcome because it's still a asterisk.
Hang on though. An important nuance here is that when you say the problems with Lightning Network, we got to be clear here that cluster, mempool, and these kinds of things fixes a sort of like a 5% issue. These are edge cases that affect Lightning in certain scenarios that aren't very common. Lightning, in the vast majority of cases, works fine with the current mempool policy. There is just edge cases where we think, oh yeah, this might be exploitable and so on. And this gets back to, we solved all the hard problems, the stuff that was easy to make a bunch of progress on. Now we have these edge cases that are left.
Look, channel factories.
We still don't have like L2 or things like that. There's like massive like state databases for Lightning.
No channel factories, no vaults.
We
have major things that aren't solved yet. You're saying we've solved all the important things, but there are major unsolved things that literally contribute to the fact that that almost all institutional Bitcoin is held at just 2 or 3 custodians, and that's partially because of the difficulty of building a custody solution, which is because of limitations of Bitcoin consensus. So it's simply not true to say that we already solved all the important things. We're just not doing important things anymore.
I really can't agree with you there. The hard parts about Bitcoin adoption right now are really thorny issues around like legality and tax law and all this. I mean, the U.S. going and charging fucking capital gains on Bitcoin transactions, that is a much more important issue than any technical thing.
¿Por qué no los dos?
CZ.
Sorry?
Why not both?
Look, I think when you compare one to the other,
another meme.
Look, we're tech guys. We're not we aren't that effective at working on this stuff, so we wind up working on our own thing. But when you look at the grand scheme of things, if you want Microsoft to go and be, using Lightning to like everyday people, I'd say that's a much bigger problem.
Well, so I'll leave you a quote from actually from Wumpus, I believe. I could be wrong, but at one point I proposed, hey, everybody wants to use Bitcoin Core, wants to use Bitcoin Core Wallet. One of the problems, this is an email that I sent, I believe it should be on the mailing list somewhere, is everybody has a basis for their coin, and when you spend that coin, you have a tax exposure, and because you can't actually tax plan inside of Core, it makes the wallet almost unusable. So even though it's a local concern, like many places have these capital gains rules. If we could add to the wallet functionality, we could probably increase the number of people willing to do transactions if it was easy for them to know how much this transaction is going to cost them. And I believe the response was you should make that change through voting for different politicians who will repeal all your taxes rather than like make Core like more functional for users.
No, Wumpus is right on that. I mean, that gets into political stuff because like ultimately the idea.
But you just said that the main thing that we're struggling with is political things. So we can't write any code that makes the political things easier.
But no, because that doesn't make it easier because it's agreeing to it.
It does too, because you could say, I don't want to pay more than X taxes on this transaction, so I'm not going to spend UTXO if the taxes are too high. Yeah. Right? Like that's actually a rule you could have in a wallet that would be useful.
Well, I mean, look, no. I mean, the reality of laws is that if you have mass disobedience, the laws get changed. I mean, look at Uber.
But if you can't get that adoption because of that lack of functionality, then you also can't.
Which gets back to we're much better off with people getting jurisdictions taking these limitations away. And look,
it also solves the controversy problem because if fewer people are using Bitcoin, we'll have much less controversy.
A bit of accounting software isn't going to change
you just
really
said,
big business problems.
You just said the reason that people aren't using Bitcoin is because it's hard to pay taxes. And then you said the real thing is that people just shouldn't pay taxes.
We got 3.5 minutes left.
You are all retarded.
Is fundamental here.
Everyone on stage, you are all.
We can
retarded.
all agree.
Says the man in
we
the
can all
pink
agree
hat.
that we're all retarded. We have time for one more question. Anybody have a question?
I don't know if this is too big for a last question, but it does strike me that you guys just mentioned about the fact that the quantum thing is the identification of the right root problem, but the wrong kind of surface or branch issue, right? Like the problem there is also, it strikes me quite similar to the knots versus core debate, where like client diversity is actually the root issue, and I think we should all probably be in favor of more client diversity, but the construction of the debate in public is radically malformed compared to like the actual underlying issue. I'd be curious what your guys' thoughts are about the fact that we seem to be, at least in this generation of Bitcoiners, afflicted by the inability to have constructive conversations about the actual root issues versus getting drawn into these, you know, kind of what I would call navel gazing or superficial sort of, you know, low information debates about things that are actually irrelevant or meaningless. Like, what is the cause of that, or like how do we overcome that, or like how badly are we being wounded as a community by being unable to come up over the top of this issue?
Well, I think we have two problems, and one is that we're all retarded, and the other is that we're all autistic. And in that situation, it is very hard to not get sucked into rabbit holes and bike sheds.
I think that what I would say is we're in a very inspiring venue. We're at the, are you done? Okay. I don't know what the laughing was for. So we're in an inspiring venue, you know, the Hoover Dam, which is like a massive engineering project. Maybe it's the wrong thing because I'm looking at the water levels, but you know, it's a massive, inspiring infrastructure project. And a lot of these things take someone being like, okay, we're going to build this, and we're going to, you know, solve for this problem, and we're going to do this with a concerted effort. And then after we finish that, we'll do the next thing, and the next thing, and the next thing. And I think as a society of Bitcoiners, which is, you know, what we're doing is, I think dedicated directional problem solving is probably the way that things move forward, because you want to put the things that are going to kill Bitcoin in the rear view mirror, not leave them in front of you for, you know, avoiding them at some point later. It's just put more reasons to die in your rear view mirror and move on. It would be sort of, I think, part of this gap that you're noticing of like, okay, well, why is it that we've had proposals for solving quantum on Bitcoin for 5 or 6 years now, and nothing's tangible? You know, that would be, okay, we need a culture of putting problems in the rearview mirror.
I mean, I can give you a very easy answer, which is like all of the solutions quantum suck. Now, let's say hypothetically someone came up with something, used as many bytes of signature, computed as fast, et cetera, as say Schnorr, and it was quantum safe. It'd be much easier to get the stuff involved. But all of the quantum secure stuff we have is massive trade-offs. And those massive trade-offs mean that in the face of very real and very genuine uncertainty of whether quantum computers will ever actually be real, the obvious answer is, well, let's go and like wait later. Now, going back to like client diversity, of course, if people actually have pilot client diversity, all this stuff becomes harder because now you have a zillion subtly incompatible different things. All these solutions are actually easier if you have less client diversity. And that's the only way, you know, consensus software is ever going to work right now. And, you know, the Hoover Dam is a great example of this. We look at this thing and think, oh man, this is so complex. It's such an amazing engineering achievement. No, Hoover Dam is way simpler than Bitcoin Core. Way simpler.
I don't know if I was asked because I'm technically the moderator, but I would say I think there's 3 circumstances under which like big risky changes are undertaken. One, if there's basically no risk, so when the project is much smaller and not worth trillions of dollars. 2 is if there's an emergency, and so you kind of like have to rush to do something, and it like forces everybody into action. You often make bad decisions that way too. And then the third is if there's like financial motivation. So like companies will often are willing to take on big risks because they're either going to like go out of business, or they're like want to like take a big risk to make a lot of money. Like Nvidia is a recent example of this. Some of the risks that they took in terms of investments in AI chips. And I think the problem is like Bitcoin is worth a lot of money now, so the financial motivation to like solve the next problem is not as high. The risks are really high, so we don't even want to try and get activation clients in place, not let alone like actually activate them. So the risk is just like, well, I don't want to touch that, put that onto the wallet, and then we will do something in the next emergency. And like this is like ultimately how SegWit got activated, and you know we might make a mistake in that. And so that's it's purely subjective. I don't know if it's right or wrong.
SegWit wasn't an emergency though.
I agree, but people perceived it as an emergency when like okay, well the ecosystem was kind of losing its mind at that point in time, and fees got up to like $100, and so people were like, well, we got to solve the block size. It was a manufactured emergency, but that's often how.
Right, and that's a really important thing. People knew it was a manufactured emergency.
Not everybody did. Yeah, but
among my side, we knew it was manufactured.
yeah, I believe you. But again, this is how, like, that's one way things can get co-opted. Is you can manufacture controversy to kind of like get an issue through in place. So it's like, oh, maybe somebody will forge proof of quantum computers to get something in place that they actually have some backdoor to or something. It's like a totally manufactured example. And with that,
Totally manufactured.
With that, thank you everybody. Thank you to the panelists and everybody indulging us. This was a lot of fun.